Good morning, everybody. Good afternoon, good evening, good middle of the night, wherever you are. And happy whatever day it is if you are watching this in the future from now. My name is Maddy Montaquila. I am a PM on the .NET team. I'm working on .NET Aspire right now, as you can tell by my amazing art here. And I am very, very excited to kick off today's Azure Developers .NET Aspire Day. And so we have like almost 4 hours of just content, different lengths and topics, and all of the different things that you could ever possibly need about learning about using Aspire and Azure. So before I kick it off to Brady, I want to explain quickly what is Aspire, because we get this question all the time. Aspire is kind of a set of tools and packages and a whole bunch of different things that you can use to make your modern app development easier. So when you have all of these different resources in the cloud and your backend and your front end and your API and your blah, 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 all these things, working with all of them together can be really difficult, right? And we see this all the time. And so Aspire is a whole bunch of different things that make that process easier and help you get it into the cloud quicker than ever, which is great. And so, of course, we love Azure. Azure has great Aspire support. We've worked really closely with a lot of the folks on the Azure team to make it a really smooth experience. So, that's what today is all about. We're going to dive into a whole bunch of different topics, ranging from Aspire integrations to deploying into Azure with AZD, ton of stuff. So, couple housekeeping things before we get going. First and foremost, you just saw the agenda float by on the bottom, Azure Developers .NET Aspire Day. So you can go and see all of the different things we're coming on, that we're going to bring on, set the alarms on your phones or whatever, and note down the ones you want to watch later. Second of all, we have a collection, a Microsoft Learn collection, which is a whole bunch of different links and resources and repos and blogs. There's a bunch of stuff in there. And so we'll give you that link periodically throughout the day so you can go and check all of those things out later, including something like our eShop sample app, which you see a lot of, and the information on .NET Conf, which is going to happen on November something, 11th, that week of November in a couple months. So that's when .NET 9 ships, Aspire 9 ships, and there will be some really exciting news and announcements for Azure developers using Aspire at that event in particular. So without further ado, I'm going to kick it off to my good friend Brady Gaster. And he is talking about building new and retrofitting old apps with .NET Aspire to streamline your development process.
Hi, I'm Brady Gaster, and I am a PM on the Azure Tools crew with Visual Studio. So my job is to make it easier for you to build .NET applications using Visual Studio or .NET Aspire with Visual Studio so that you can party in the cloud. So what I'm going to talk about today is going to be a couple of small agenda items. The first one is kind of going to be a refresh into how you would get started in VS with a brand new Aspire distributed app. And then I'm going to show you kind of how you would do that at piecemeal using some of our tools and to add Aspire integrations, or as they're formerly known, components. And then the last thing I'm going to show you is how you could bring an existing kind of a simple web application, kind of your traditional two-tier ASP.NET Core plus SQL application, say running on app service, where you've already got like a deployed environment set up, and you want to use Aspire to kind of develop locally and you get the benefits of the dashboard when you're trying things out. So without further ado, let's go ahead and jump into Visual Studio and get started. So you'll see here that I've got Visual Studio open. I'm going to zoom in on certain dialogues from time to time because I've got my resolution set as big as it'll still fit everything, but still there's a couple of dialogues that are small. I'll do my best to zoom in from time to time with that handy tool, Zoom It. So the first thing I'll do is I'll select New Project, and I'm going to start with an Aspire Starter app. Now we have a couple of other templates in here like .NET Aspire Empty. And we've also got .NET Aspire templates for the startup, for the app host project, and for the service defaults project. I'll show you those in a moment, but what we'll start with now is that Aspire Starter app. I'll click Next here. I'm just going to call it Aspire App 3, put that in my source folder. click next, and I'm going to go ahead and turn on configure HTTPS because security. I'm going to turn on Redis, and I'm actually going to create a test project using MS Test. I'm going to go ahead and hit create right here. And what you'll see now is that the package is going to open up. I've got a couple of, as an internal build, so I've got a couple of new packages coming in. You'll see that the Aspire project is going to open up and kind of get me ready. Just kind of explore all the parts. Here's my app host. You'll see that a lot today. It's just kind of a one-stop shop for your entire Aspire application. I've got this API service backend. I've got this web front end, which I'll leave open here. And then I've also got a tests project. Now, this test project, what it'll give me the capability to do is actually use the Visual Studio test features or the VS Code test features. I can actually run this test, and it will fire up the Aspire runtime and hit individual endpoints in my runtime and make sure the individual services are up. I'll close that test project down. And at this point, what I'll do next is I'm going to show you kind of how the integrations work, how Aspire integrations work. Now, I've got an integration that I need to add to this front end. I'm actually going to, actually I do it to the back end. I'm going to add SQL to the back end. You'll see me do this a little bit later on, but I'm going to right click on this dependencies node. I'm going to zoom in so you see that we've got this add.NET Aspire package, a node right here that's along with your NuGet packages and other dependencies. I'll right click on that again and just say add.NET Aspire package. And since I'm in that API service, it's going to show me a list of client packages that I might need to use in my app. I'm going to use this Aspire RabbitMQ client package. I'll go ahead and click on install here. That will install the RabbitMQ stuff into my API service project. And I'm going to close this down and go to the front end, actually to the app host here, and right click on dependencies. Once again, selecting this add.NET Aspire package. And you'll see a slight difference when it opens up, and that's that this will be filtered for hosting. The reason for that is earlier I selected a traditional web or API project inside of Visual Studio and said I wanted a .NET Aspire package. So Visual Studio knows that what I really want is one of those client packages so that my app code can actually make use of that service. Now, when I do this in the app host, it knows that instead what I'm going to need is a hosting package to kind of enable that hosting capability inside of Aspire. I'm going to want the RabbitMQ host, so I'll go ahead and click install. Now, the idea here is that I've just installed the RabbitMQ hosting package into my app host project, and I've installed the RabbitMQ client package into my backend client project. Now, at this point, I would kind of do var rabbit and RabbitMQ, and I would say builder dot add RabbitMQ, how we give the name, and we just go from there. And at this point, what it's going to do is that would come in as a container. It would be running when I hit F5 inside of my dashboard. Go ahead and show you that. I'll just click run right here. And what we do is we pre-wire all Aspire starter projects such that the app host is the startup point. And the app host will essentially know how to start all of those other projects and set all those references around individually. So you'll see here that I've already launched my browser window open, hide my bookmarks so we don't have any distractions. We'll pull this in and you'll see here's everything. Now this one will be starting. That means it's actually pulling down that RabbitMQ image from Docker, and you'll see now that that is running. I've got the API service here in the web front end. And if I wanted to actually try these out, I could click on that web front end. You can see here that here's my counter, and if I hit weather, you'll see that that's going to be a cached response. It's actually going to put the response of the API directly into Redis. And if I were to go over here and look at traces, you'll see the dashboard a bunch today, so I won't explore it too much, but you can see how that traversal is happening and make a call to the front end. Front end makes a call to cache, and the back end setup. So that's kind of how we got everything going. So that's kind of your file new experience if you haven't worked with Aspire yet and you kind of want to get up and running with it. One thing I do want to show you, however, is if you want to kind of onesie-twosie this, like you know that you're going to need some back-end resources. So you want to kind of start with your app host, and you know you might need a couple of other nodes, but you kind of want to go one at a time. For whatever reason you're going to be adding these individually. So I'm going to kind of walk through that process real quick. So first thing I'll do is just say file. We're going to start over, new project, and this time I'm going to pick empty .NET Aspire empty app. All that's going to do is that's going to drop in that app host project. Let's say Aspire empty app. That's going to essentially drop in that app host project. and the service defaults project, and then not do anything else. If I wanted to add anything to this project, I would essentially right-click my project. I would go to my solution. I'll go here, add new project. I would pick Blazor web app. I would just leave that web front end. Here we go. I'll click next. Now this step is great. It sees that I've already got an Aspire solution directly inside of Visual Studio. So what it's going to do is it's going to show me this enlist in .NET Aspire orchestration checkbox, which will essentially be a one-click way for me to bootstrap that web application that I just added to my Aspire project, really my only client project in the Aspire solution, directly to my app.cs. You can see here that we go ahead and drop in the line of code, and if I wanted to right now, I could just hit F5. And what should happen is that dashboard will open up again, and we will see that web front end as the only resource in the Aspire app. See here it's spinning up. There we go. Right here, I'll just click the front end, and now we're good. That's all hot. So that kind of shows you how you can really go piecemeal. You just want to get started with an empty app and kind of move on from there. Okay, so this is the part that I'm really excited to show everybody. We've had a lot of questions from folks around how to kind of do like dev provisioning from within your Aspire app. So I might have some sort of a resource that I can only, party on when it's actually a deployed resource. A good example of that would be Azure OpenAI. So what I'll do now is I'll right-click my dependencies node for my app host, and I'm actually not going to write any code to make use of that Azure OpenAI resource. I've got some code that I'll show you here in a moment that will do that for you, or a sample for you. But I want to click .NET Aspire package here in my app host project, because what I want is the OpenAI or Cognitive Services hosting pack. I'll do a search here for hosting for OpenAI. Here's my Aspire hosting Azure Cognitive Services package. I'll go ahead and click install here, and I will get that OpenAI stuff embedded into my app host. And now I'm going to need to write a little bit of code. So I can't remember from time to time how to do some of these individual little, playgroundy kinds of things. So what's really good is that in the Aspire repository, we have this folder right here called Playground. You'll see that I'm at github.com github.com/.net /Aspire right here. And what I'm going to do is I'm going to go down and click on Playground. And the Playground project that I want is this OpenAI end-to-end. You can see we've got Oracle end-to-end, parameterized stuff end-to-end, the Postgres end-to-end, et cetera, et cetera, et cetera. But today what I want to look at is this OpenAI end-to-end, because I know Sebastian and Mitch have some really easy to copy code in here that I can party on. So I'll go in here to this app host. I want to go to that app host's program CS. I'm just going to copy this code right here, and I'll walk through what that code does when we get back into our favorite product, Visual Studio. So I've just put a couple of new lines here. And what you're going to see is I've got this deployment model name. I'm not going to be using that anywhere else in my code, so I could just drop it in right here, but I'm not going to do that. I'll walk through what the code does. This line right here, add Azure OpenAI, will basically create a new Azure OpenAI resource out in my Azure subscription for me. Then it will add a deployment. The deployment that I want is the GPT-4o deployment, the new one. So I'm going to party on that in my application later once I have a little bit more time to write more code outside the demo world. So what I'll do next is open up my timer to make sure I'm not going over. And then I will come over here and I'm just going to hit F5. I'm not going to add any code. And that will open the app up in the dashboard one more time. But this time we're going to see an error. I'm going to walk through what that error looks like for you. So what you'll see here in the dashboard is that we have this error that says missing subscription configuration. And if I were to scroll over here to logs and click on logs, zoom on this, it's going to say resource cannot be provisioned because Azure subscription, location, and resource group information is missing. And then here's a link where you can learn how to do it that goes out to our docs and kind of teaches you what you need to do here. I'm going to show you a nifty feature we've got inside of VS to kind of make it automatic for you. Essentially what we've got is this feature we're calling Azure Auto Provisioning. Now for me, I've got an Azure subscription that I party on, log into it with my personal sub. I pay for it myself, et cetera, et cetera. So I am an owner of that sub, both from the perspective of logging into from VS and from the portal and the CLI. I can do anything with that sub. Not everybody's in that situation, but if you have your own test sub where you can kind of create resources and kind of go fast, this is a really great feature for you. If you're in an environment where your Azure subs are locked down, might be a little bit more complicated, but you can get your admins to kind of set you up with access to one resource group or whatever, so you can kind of do what you're going to see me do right now. So what I'll do is I'll right-click on connected services inside of that app host project explicitly. This will only work in the app host project because that's kind of your host for all of your stuff. It sends all the variables in to all the other projects. You'll see that I've got this Azure Resource Provisioning Settings option right here. I'm going to click that again. And what it's going to do is it's going to ask me for the subscription that I want to party on, the location that I want to party in. So I'm going to say East US. Then the resource group that I want to create a new one. So I'll call this Brady G Dev 001 because I'll probably create a few of these. And I'll click OK. And then I'll click OK one more time. And it's going to go out to the Azure Fabric, create that resource group for me. Now when I hit F5, we should see something slightly different inside of our dashboard. What you'll see this time, I've configured it properly, is that, let me look here, it is now going to compile that ARM template. So what's happening is Azure Auto Provisioning is now figuring out what it needs to do, like what resources will need to be provisioned inside of my Azure subscription. And then it's going to go out, create that resource group, build the Bicep or ARM templates that it needs to kind of deploy everything. And then it's actually going to execute that deployment directly against my Azure subscription. The idea is essentially just-in-time resources so that your application code can be written. This is really helpful for situations like OpenAI, or when you need to use live resources in Azure, such as storage or Cosmos DB or something like that. You don't want to use an emulator, can't install an emulator, or it's just your team's practice to kind of use live resources. What you'll also see is that the resource link, as it's doing its provisioning, is a link directly into the Azure portal. So if I wanted to go into the Azure portal and actually watch that deployment take place, I could. Now I have the Azure portal open right over here. So what I'll do is I'll go into that dev resources guy that I just created. Oops, we'll do that again. Let's say that again. I'm going to close that down. So I'll start here. So you see there, now it's already running. So that means that this provisioning has already happened. And I'm going to drag in my browser window, and you'll see this is that resource group that I was talking about. And there is that OpenAI resource. If I were to click on that OpenAI resource, I could now go in and start making some tweaks to that resource. I could look at the model deployments for it, go right here into the OpenAI Studio. You can see that it has not only created that OpenAI resource, but it's also created that GPT resource or that GPT deployment for me as well. And it did that all by me just configuring it using this handy feature right here, Azure Resource Provisioning Settings, and then just hitting F5. Again, that's for folks like me who they have your own Azure subscription and you want to kind of get started like that. Now, the last piece that I want to show you is probably the longest demo. And essentially the idea behind this is you've already got some ASP.NET code. Kind of your traditional scenario is like I've got an ASP app that uses like a SQL Server backend or Azure SQL backend to do some simple stuff. And I've got it deployed to app service Linux or Windows. Now, there's a lot of .NET developers who are in that scenario. They probably already use AZD to do their deployment, or they have some other CI/CD process that they're already running. And really what they want to be able to do is this F5 experience to be able to add integrations and kind of move fast. Good news is you can do that because .NET Aspire is .NET. Everything that you've already learned how to do with .NET, you can continue to do inside of .NET Aspire, and all the deployment capabilities that you already used, you can still use. So I've got a great sample out here. It's the AZD Blazor template written by my good friends Jason and Shane. And this is the exact topology that I'm referring to. It's essentially a Blazor, front-end web app. And that Blazor front-end web app gives me the capability to just access SQL Server. And the way it does that is using ASP.NET Identity. So that ASP.NET Identity is essentially a database of user accounts that have created user accounts on my system and have given themselves the ability to log in using that SQL Server process. Now, I've already got this deployed using AZD right here because, that AZD template made it so easy. So here you can see that I've got the SQL Server, and right there I've got the SQL Server database, and then up here I've got my app service. So everything's already deployed, and if I were to go into this app service and click on Browse right here, you'll see that it's going to open up. And if I were to go here to auth required, that's my sample user, click login, and that sample user should be logged in immediately. And now I'm logged in. So you can see that this is a front end app that is talking to a Azure SQL backend database, and everything is continuing to work just fine. Now, what I want to do at this point is I want to open that project up in Visual Studio and essentially, to quote my good friend Donovan, rub a little Aspire on it. Kind of want to make it easier for me to, party on it locally. So I want to go to File, and then I'll open Project or Solution. I'm going to go over here to my source folder, source. I've got this AZD Blazor demo, and I've got this web project right here. So I'll just open up this web project and can say, kind of have to do a couple of updates on my NuGet packages first. I'll go ahead and click on Updates over here. Got a couple of NuGet packages I need to update, so I'll just click them all and update. You might have a few more. You might, need to massage that a little bit more, but, I kind of want to get all my packages up to date before I start doing anything with Aspire. So at this point, you've already seen me right click on one of these projects, or on the File New experience, you've seen me use add project to Aspire orchestration. Good news is we've given you that capability right here on the right click menu as well. So I'll right click on my project. I'll go down here to .NET Aspire orchestration. You can see that dangling off the add menu right here, and that's on any web project or other projects. So I can go here to add .NET Aspire support. I'm going to make a couple of changes here because I'm kind of persnickety about the way I've got my files organized. So I'll click Browse. I'm just going to back up one folder to source because I want my service defaults project and my Appos project to sit in the same folder as my web project. So I'll select that, and then I'll just click OK. And the final question should be, now that you have a few projects in this solution, we're going to want to make a solution file. I don't want to put my solution file in web. I want to put that at that root. So I'll back up to source and I'll hit save. And there we go. So now we have this solution set up. You can see that I've still got my web project right here. And I've still got my Appos project right here. I've got a new Appos project here. And then I've got this service defaults project here. Now, we're going to have to make a couple of code changes in the web host project because we need to support, SQL and Entity Framework. If I were to open up the program CS for my backend project, for my front-end project, you'll see that right here, we're getting the connection string from Key Vault. And you can see that I'm just calling it default connection, and I'm using the application DB context, which is the Entity Framework database context that you get with ASP.NET Core Identity. So that gives me all the users and roles and everything else I need to be able to do in that SQL database just automatically. So what I can do now is I can right-click on that app host project right here, and I'm going to say add .NET Aspire package. So you've done this already. Add .NET Aspire package, and I want to do SQL, Azure SQL. So I'll type SQL right here, and all I need in my app host project is this aspire.hosting.SQL server package. So I'll go ahead and click install. That's going to install that into my app host. And now I'm going to go over here to my web project and kind of do the same thing. I'll right click on dependencies and I'll hit add .NET Aspire package. And real quick, what I want to show you here, you'll see that it didn't load. Again, I'm using an internal build, and in this build, for whatever reason, sometimes when I do that second right click add Aspire package, it doesn't register for some reason. So the way you can work around that until we fix it is you can right click your project and you can go unload project, and then you can right click that project again and say reload project. And I had that program CS open, so I'll go ahead and open that back up. And now I can right-click dependencies, and I can say add .NET Aspire package, and the dialog will pop open. So sorry about that. Working on it, trying to get that one resolved before ship. So I'll go ahead and type SQL one more time. And remember, since I'm using the application DB context object inside of that web project, since I'm using ASP.NET Identity, I'm already using Entity Framework, and clearly I'm already using SQL Server. So on my web project, I'm just going to do aspire.microsoft.entityframework core.SQL Server. I'm going to install that into my web project and click I accept. Now, as mentioned, there's a little bit of code we're going to need to write both in the Appos project and in my web project. So I'm going to walk through that now. First one is going to be the Appos. So we're going to need to create a SQL Server and a SQL Server database. So I'll go right here because we know that the name of the connection to that database and the front end code is default connection. I'm just going to copy that, and we'll say var SQL Server is equal to builder.add SQL Server, and we'll just call it SQL Server. And then you do that, and that lays down essentially a reference to a SQL Server. At this point, the Appos would pull down the SQL Server container and run that directly on my machine. But I'm going to need a database in that SQL Server. So what I'll do now is I'll say var SQLDB is equal to SQL Server dot add database, and we'll paste in default connection right there. Now I want to reference that database from my web project. My web project's going to use it. So I'll just say with reference, and we'll pass it SQLDB. And what that essentially will do is create the database server and create the database inside of that database server, get the connection string for that database, and then inject it directly into my web project so I can just run. Everything will work. But there's one final step, and that step is that I need to enrich the code that I've already written. So the idea behind enrichment is that I've already got this application DB context, and I've already got a connection string that I'm either reading from configuration or hopefully from Key Vault in the deployed situation, or I'm using managed identity to directly access that database with my logged in credentials. But I don't have any of the Aspire goodness yet inside of that application DB context. So I want to enrich it. There's one line of code that I would need to add to be able to do that. I'll go right here and I'll just type builder, and we'll say enrich SQL Server DB context. Click that here, and I just want to pass in this application DB context as the parameter, and I don't need to customize that call. I can just leave that alone. So again, just to kind of reflect on what we've done, we have installed the SQL Server hosting package into our Appos project, and then we wrote a couple lines of code to create a SQL Server and a SQL Server database in it. And then we reference that SQL Server database from our web project. Then we add the, let me make sure I get the right name for you. We do the aspire.microsoft.entityframework.core.SQL Server package. We install that into the actual web project that you brought to the party. And then you go into its program CS and you enrich that application DB context. If you mouse over that enrich method, what you'll see, if we get the IntelliSense, is it going to give me the IntelliSense? No, you need IntelliSense. No, it's not going to give me IntelliSense. Yes, because I'm presenting. It essentially would show you that it's going to add health checks, retries, telemetry, and all the good stuff that you love with Aspire, and inject all the connection strings and variables in the right place. So at this point, pretty much ready to go. So I'll go ahead up here and I'll click start on my debugger. That will open up in the dashboard one more time. Here's my console window running, and here comes the dashboard, and you can see now we've got that SQL Server, the actual machine in the form of a container running. Here's my SQL Server database resource, which we've named default connection. It's basically the name of the connection string to it. And then there's my front end. So let me click the front end. Looks like it's working. I'll go over here to register and just create sample at user.com, give it a super complicated password, and I'll click register. And then I'm going to go through this process. I actually read these docs to figure out how to send an email to actually show somebody how to confirm their account. We don't need to do that right now because we're in dev. I'll just go ahead and confirm that account, and now I'll go to auth required, and I'll log in with that same account, and now I'm authenticated. If I go here to sample at user.com, you can see that we're authenticated. So this is the user experience indicating that this front-end web app is successfully talking to that SQL resource in the backend being right here on my machine. But if I were to click on the logs view for that front-end web application, you'll see all of the Entity Framework logging happening, showing all those SQL commands back and forth to the database, showing that everything is indeed working. If I were to go here to traces, you would see that those calls are getting made back to the database as well. So that's all good. Where actually everything seems to be working fine. And at this point, the true test is going to be for me to open up a console window and to cd into that directory, azd blazor. I'll just go here and I'll just say azd list just to make sure we've got all those environments. And the one that I've got active is that one right there. I don't want that one active. I want this one active because it's the one that we have deployed in my Azure subscription right here. This is the one that we have deployed right here. So what I'll do now is I will say azd I forgot the sets, and I will copy this one, paste it here, and then I can essentially do azd up, boom. And what you'll see it do is it's going to spin up that azd process. Now I've already got this set up in my sub, so it's just going to go ahead and use all the existing stuff that I've already got. It should not say you've got a new Aspire app. It should just go ahead and deploy it for me. For some reason, I didn't select the existing environment that I already had, or I'd accidentally deleted that environment or whatever. But you can see what it's doing now is it's not doing the essentially easy way of packaging everything up and presuming that it wants to go to ACA, the container apps. It's actually using the AZD template that I pulled down that basically deploys everything up to app service with SQL Server and Key Vault. So it didn't change anything about the deployment. I didn't have to change anything about the code, save one line where I enriched the DD context. And essentially, I can continue to use what I was already using. The reason I wanted to show you this, we've had a lot of customers say it looks like I have to kind of enlist with everything that Aspire gives me. It's like an all or nothing. It's not. .NET Aspire is .NET. If you already have something you're doing, you can keep doing that. There might be a couple of things you need to do manually, such as if I wanted to go in and add an API backend, this web project front end. It's not going to automatically wire everything up for me inside of App Service. I would have to do that manually. I'm already doing that manually, so it's not like my life's going to get any harder, but my development stuff is going to be easier when I'm F5 and trying code out on my machine because I'm using .NET Aspire. So the idea behind this is you take your existing code, rub a little Aspire on it. Thank you, Donovan. And now you can just kind of, party locally as easy as you can in the cloud. And as you saw with our auto provisioning, if you need to party in the cloud right away, right off the bat, you can do that as well, as long as you aren't under in your sub. All further ado, I want to say goodbye. Thank you for the opportunity to talk to you today about all the good stuff we're doing with .NET Aspire. Please enjoy the rest of the speakers, ask questions, leave comments, and file issues. That's how the product gets better. Thanks a lot. Happy coding.
Thanks, Brady. Wow, that was pretty good. Rub a little Aspire on it. I think I'm going to have to use that from now on. I've been saying Aspireify, but I think that's a little bit better. Hope you all enjoyed the first talk. A couple of housekeeping things. We are seeing all of the things in the chat about the quality. So what happens is our streaming software is compressing these videos a little bit, but the code is, everything's zoomed in when we record it. And so on demand, the videos with the actual code will be sharper. So feel free to go back and watch those later if you want to see like the fine details. And make sure your YouTube is set to 1080p if you're not already. But everything will be on demand after. Hopefully things start to clear out with quality-wise throughout the day. But live events, we love it. Oh yeah, that's okay. Brady says it's Donovan's. Thanks, Donovan, for rub a little Aspire on it. And okay, cool. So couple reminders for those of you who joined partway through that. First and foremost, we have an amazing collection on Microsoft Learn filled with a bunch of different pages and sample apps and other things, trainings to get you, started with and more of an expert at .NET Aspire and Azure. We also have a Learn Challenge. So if you want, you can go in over the next month, complete a subset of learning we picked for, Azure Aspire developers, right? And compete on a leaderboard to see who I don't know, learns the most fastest. There's a lot of cool things about it. It's very fun. And all these links are coming in the chat right now, by the way, from our Azure developers account. So thank you, everybody behind the scenes. It's not just me. And then, of course, we have a survey. We always love surveys here for the whole event. So it's on the collections page. but it's also, we'll pop it through the chat throughout the day. Please let us know what you think of this event. If you like this kind of format of just like 3 or 4 hour short streams or whatever it is. And, especially what you want to see more of at .NET Conf in a couple months. So that is my rant. I will have that rant like 6 more times today. Sorry in advance. But we are going to pass it over to Chris Ayers, who is aspiring. He says not rubbing Aspire on it. So Chris Ayers, aspiring .NET applications with Azure OpenAI. So take it away, Chris.
Hello, everyone. Thank you for joining us for .NET Aspire Day. I'm going to be doing a session on aspiring.net with Azure OpenAI. Show how we can integrate AI services into our Aspire applications. So my name is Chris Ayers. I'm a senior customer engineer at Microsoft. I'm on the Fast Track for Azure team, which is part of CXP, Customer Experience Program. I speak and blog a lot, and I have quite a few demos and samples out on GitHub. So please go out there and check out what I have or see my blog. Today, we're going to talk about, and I'll go over these kind of quickly so we can get to the demos and have some fun with code. But why .NET Aspire? Some of the integrations available, how to consume some of these resources, local Azure development. And this is what we'll be leveraging quite a bit, as well as deploying to Azure through the Azure Developer CLI. And then, like I said, lots of demos. So .NET Aspire is designed to improve the experience of building cloud-native apps, .NET cloud-native apps. And this is what I love about Aspire, because there are some pain points, and Aspire helps solve a lot of these through orchestration, through integrations, and through tooling. And like I said, I'll move through these rather quickly. We have a whole day of .NET Aspire, so I'm going to reiterate, I guess, a little bit, but when I have multiple services, an API and a front end and a back end, and I want to spin them up, I don't want to open multiple windows or tabs or terminals and run the commands over and over again. Being able to quickly configure my apps so that they talk to each other easily through connection strings is super easy, and credentials. I love the monitoring and logging capabilities of the dashboard. And I can easily spin up containers for backend services like Redis or Postgres or SQL Server. And so these integrations are incredible. Like, we have so many of them. I can run local emulators of things. I don't have to worry too much about authentication. And integrating them is relatively simple, just through adding some NuGet packages. I don't have to dive deep into infrastructure of code. And the tooling is great on both the Visual Studio side and Visual Studio Code. There's some great templates there. The .NET Aspire dashboard is incredible. We'll use that quite a bit. And, the app host really lets us coordinate all the different pieces of our application and handle that distributed aspect of it. And then service defaults let us bake into our application best practices and policies that we want through retry and health checks and all of those things that are best practices. So those integrations, there are 2 sides to it. One side is the hosting side. So in that app host where we lay out our dependencies for our project, this can manage our resources. It can help automate that infrastructure setup and really drive the configuration, the wiring up of our various services. We don't have to start 5 projects in Visual Studio. We can just start app host. And on the client side, it makes it really easy to consume those different dependencies and resources, those integrations, through service discovery and just wiring up things through the configuration. And like I said, the service defaults and logging. So these really come together in a wonderful way, and we'll show that. I'm going to take you through a journey on some code. And we have integrations for not only .NET applications and .NET projects, but maybe I need to invoke a Node front end. Maybe I'm doing something with React. I want to just invoke that through my app host. I can do that. Or if I have some Python code on the back end and I want to integrate that with Aspire, I can. If I easily want to spin up a container That's quite easy to do. And I don't have to go hunt around and figure out what port things are running on. I can be very explicit in how that's configured in .NET Aspire. And then I have all sorts of services I can use and consume. And we're going to deal with OpenAI today. But if I was running it locally on my laptop, I could change it, maybe spin up a Docker container and do a Llama. If I wanted to start building a RAG application and have data and Postgres or SQL Server, I could leverage that. We might look at adding Redis to our application later, or if I had some messaging or storage. There are lots of great integrations baked into .NET Aspire, and it's open, so it's all extensible. And as we go through and we try to consume some of these resources, I've hit on quite a few of these a couple of times, but service discovery and defaults, service defaults, they're wonderful. If I use launch profiles in Visual Studio Code or for my different .NET applications, .NET Aspire respects those. It pays attention to them. If I want to make sure I have health checks, if I'm running a containerized workload and I want to have some sort of health check to make sure my container is running successfully, those are part of some of our service defaults enabling those. Even telemetry, so that we can use the dashboard and have distributed logging and tracing. And when I talk about service discovery, this is the really cool part. Some components, and I'm sure we're going to touch on this in other sessions, want connection strings. Others maybe just expose an endpoint, a URL, a port. And so depending upon the services I reference and use, it provides what's needed to the client side. So if, for instance, I make a backend API and I pass that reference to my front end, it might just pass API service and then the port for HTTP or the port for HTTPS. If I'm referencing Redis and that started in a container, but I would connect to it with a database connection string, it might create a connection string environment variable. And because of the way .NET configuration works, it loads these into the configuration system. I can override them with app settings, with other environment variables. And so it's a very easy way to do some service discovery as well as configuration as I deploy up into the cloud. Which leads me to local Azure development. So not everything can be an emulator. Not everything can be a container. Sometimes when I hit F5, I need to connect to a real service running in the cloud, like Azure OpenAI. And so in those cases, I need to provision resources in Azure. And those might come from a very, wide array of sources where my credentials are leveraged. Maybe I've logged into the Azure CLI or PowerShell, or maybe I use Visual Studio to do this, or VS Code. There's a lot of different ways I can make sure that the right credentials are passed out into Azure. And I'll show you how we can configure some of these in Visual Studio for deploying out to Azure. And then once I've built my app and I started to get it running, I can leverage the deployment manifest. So I'm sure we're going to talk about this in other sessions, but the Azure .NET Aspire deployment manifest gets generated from our app host. And this is a cloud agnostic capability. So if I use just containers and stuff, it will show the different containers and ports I need to leverage. But we usually use the Azure Developer CLI. So I can go azd init and it will scan my application, and I can host my workload, my solution out on Azure Container Apps. I can get all that telemetry I need with application insights. And so going into an Aspire app, azd init, scan everything, look at that manifest. It'll generate Bicep files for me in memory and provision those out into Azure, and then it'll do my deployments. And I'll publish containers, so I don't even need a Docker file for my .NET because it can use some of the new capabilities from .NET 8 and 7 to publish to containers directly and push them up into the registry and run them on container apps. So there's some really cool stuff. So let's start doing some OpenAI with Aspire and leverage, English is our new programming language. Or if English is not your first language, you have a different native language. Most of the GPT models will work with those. So let's go play with some demos real quick. Now I'm going to start out with a super basic application. We're going to build our way up. So I'm going to have a website, and this is just a super basic .NET new, and we have our weather controller, and it displays the weather and has some random data it gets. Now, the first thing I'm going to do to start preparing my app, maybe to integrate into Aspire, is I'm going to split some things out. So I've got all this checked into a repo. I will share this, but instead of generating my code locally, how about we call it from an API? So, I'm going to go get that data from my API. And this is my weather API service. I've got that exact same code we saw before running here with the weather forecast endpoint. And so I have not added Aspire yet. All I've done is split out the endpoint. And if I look in my program, I have to put in my local host and my port. I have to override this. I have to change this when I go out and deploy into Azure. But locally, I can hit F5 and run my application locally. And I'm going to go ahead and try that now. I don't want to attach to a process. Oh, I know why. So this is where things get annoying. I have to change my startup process. This is that pain that we face where I might want multiple startup programs so that I can start these and run my application. It's not as ideal as I would like. Waiting for everything to start up and build. I've got a couple of windows opening up for me and my browser opening up. And this is what I need to do to get everything working and running. And there we go. Here's my application. I've got one here and one here. Not ideal, but I can hit my counter and click on it, and I go to my weather, and this will call my backend service. So I've got my two pieces of code running, and I can invoke it. Okay, so we've got the first step done. Let's add Aspire and see if we can make this a little bit easier. So I'm gonna move forward in my commit a little bit. And now, if you notice, we have two new project API service. We added our front end and a reference to our API service. And we've got all of our service defaults here that are going to bring in OpenTelemetry, health checks, service discovery, and resiliency, so retry. And I can look at my web page. And now I've got my service defaults added to my website, and I'm invoking my client now by friendly name, API service. And the rest of the code really is unchanged. I still got the same weather service. I'm still just calling it, on that. Everything is fine. And once you've added Aspire, you can, of course, add this to the tooling with add .NET Aspire package or orchestrator support. If you've already added it and you add orchestrator, it'll do that. Well, now let's start adding OpenAI. And this is where things start getting fun. So I mentioned all of those great packages that we can leverage. So let me just close all these tabs, and we're going to start looking at what we've done. So if we look at the app host, I've now added OpenAI and a deployment. And if I want to double check, let me look at my NuGet packages for this solution. I'm not sure why I'm not seeing this. So I will just go ahead and move up to my main branch just to get things hopefully back where they need to be. Couple of little tweaks here, and let me see if I can manage my NuGet packages again. Let's see if we can see that. I think I might have just confused it a little bit, that's all. Remember, I mentioned earlier the two halves of an integration, the hosting side. So if we look at these are extensions on the distributed application builder, and this adds the OpenAI capability, and it's a hosting package. So when I try one more time, and let's see what we get. So this is our Aspire hosting cognitive services. And you can see it's got some dependencies, but this is our hosting side that's going to generate OpenAI. And I don't have to add deployments here, but I can chain multiple deployments if I want. So if I wanted a new Azure OpenAI deployment, maybe I want it to be embedding as the name, and I want something like text embedding. I need to look up the actual model name, but easy enough to just add another deployment. So we've got our OpenAI here. We've got a deployment that will be created. I need these out in the Azure in order to run against my code. And I've added that reference to OpenAI and my chat deployment name here. So let me go ahead and double check how my solution is set up. If I look at my startup projects now, I really only need one single project on app host, and I can just go. Now this will build my application. This will start up the dashboard. And let me start debugging. So here is .NET Aspire. You can see it's going to be using default Azure credential, and it's spinning up. It's going to be doing some stuff in local user secrets. And here is my dashboard. So we should be able to run our application. And this is the first thing you need to do for local Azure deployment. So if we look at our logs here, resource could not be provisioned because subscription location and resource group information is missing. And there's actually great documentation on this. If we look here, this goes through all of the different capabilities. It talks about what we just saw, that something's missing. Now we can do two different modes, like if we're publishing or if we're just consuming, but what we're going to be doing is this. We're going to be adding to our configuration our subscription ID, and that we want to allow creation and a region. We're going to give it a couple of pieces of information so that we can actually run this deployment. And I'm going to right click on my app host, and I'm going to manage user secrets. So right now this is empty. I'm just going to zoom in a little bit, and I'm going to replace that with my information. So we got a location, we got a resource group, we got a subscription, and we're going to allow resource group creation. So I'm going to save this, and I'm going to run this again. And again, we are spinning up. Now, I've run into problems in the past. I have a number of different subscriptions, and I've run into problems in the past where the subscription I've set with some of my things is different than the subscription that I'm logged into in Azure or logged into in Visual Studio. And I'll show you those couple of settings real quick. Notice this is now compiling an ARM template. This is actually going to do a deployment out to Azure and create that OpenAI instance and create a resource group. So I have a different demo I'll show you in a minute, but if we look, it just created this resource group, and If I give it a sec, or look at deployments, we can see that there's actually an OpenAI deployment happening right now. And it's starting to create resources, and then it will create the deployment on top of that resource. So once it creates OpenAI, it'll create the model deployment as well. So let me go back to my deployments. And it succeeded. Awesome. And notice it did role assignments. It created a deployment, created all the little bits I need. And if I come here, it's finishing up the deployment for the Aspire side. It's already got my front end running, and the back end will be running in just a sec. So there we go. AI is running, and now it started my API service. So I can launch my front end. And this is our same counter app that we had before, but now when I go to weather, it takes it a little bit longer, and we'll dive into why. So this is the easiest way to start consuming OpenAI, and I'll point out a couple of things as we go in 1 second. Again, this is the first time we're running it after deployment, so it's going to actually retry a couple times, and I'll take it a sec. We go here. So notice we've got some errors, and if we look at our console, yep, so we have some resilience event occurred, and I can actually go into my traces. I can see that all the retries that happen. So yeah, the first time this ran, this didn't really like it too much. Normally I don't have that problem, but I've been messing with the code a little bit, so it probably caused an issue. Try one more time. And then we'll dig into the code itself. Let's just dig into the code itself. So I mentioned that we've wired this up with reference to OpenAI. So in our website here, we've got our Aspire service defaults, and we've got our 2 API services. And if I just look at my client, it's just doing that call. It's just making that weather forecast call. That's all it's doing. But if we look on the back end at that API service, this is where things start to get interesting. So we've added Azure OpenAI Client. This is that other side of the integration package. And so here we've got Aspire, Azure, AI, OpenAI. And so we can just use that same name that we referenced in our app host, OpenAI, we can reference that same thing in our code. And this sets up dependency injection for OpenAI clients. I'll come back to this. This is semantic kernel, but right now I'm just focusing on that. So if we look at our weather forecast endpoint, here's our weather forecast endpoint. I can just reference OpenAI client. And so I've set up a deployment, an OpenAI resource with a deployment. I've set up a reference between that Azure deployment and my API service, and now I've set up dependency injection in my code to automatically go through and inject that client into my code. Now I'm passing that client to this weather summary, and this is where I'm getting a chat client and doing a completion. I'm setting a system message on helping give me a weather description. So can you describe the weather temperature in 1 word? And then I'm returning that completion. So let's try this one more time since I restarted it. And let's see what we get. Hopefully this time it's a little quicker. I think last time I ran this, I might have set a breakpoint, but I just wanted to double check. Yep. So there we go. So it took a little bit, but you notice I've got descriptions of various things. And if we look at our resources and we go to some of our logs, we've got all of our logs. We can see the retry events that happened. And if we look at our distributed trace, we can see how it got our credentials. It used the default credentials. So if I signed into the Azure CLI, and so it tried some things and it did a retry, and I can see all of that here in OpenTelemetry. Now, let me go back to Visual Studio. Now, there's a couple of things to pay attention to if you run into weird authentication issues. One is I like to go to the options. So looking in the options, if you type Azure, there is a account selection. So if you have multiple accounts that you have access to, this is how Visual Studio will connect to Azure for debugging and auth and passing credentials. The other thing that's great is if you right-click here, this will take you to your Azure provisioning steps where you can pick your subscription and information. So I set it up through user secrets, but you can get to it either way. So yeah, we're dependency injected our client. We're using our client just like we normally would. You can go out to .NET/AI samples and see a number of ways to use the Azure OpenAI client. I set up a system message and a user chat, and then they'll just return the text. Nothing too complex here. Let's take it a step further. Why don't we run it again? And this time, let's look at a chat client. Let's make a really basic chat client. And in this case, I am going to use semantic kernel. So to use semantic kernel with OpenAI in .NET Aspire, I needed to know my deployment name. And I love how I can easily say, hey, here's an environment variable with my deployment name, called it chat. Maybe I want to add another one for embedding. I could add that here, pass that variable as well. So now I'm pulling that out of the configuration system so I can get the deployment name or default to chat, and I can pass that to my semantic kernel. Add this completion. And that's really what I need to do to wire up semantic kernel with that chat service. Now I put this code into a separate chat service that we can look at. And so it's not in line with the code like the weather summary is. I've got a little chat service here. And if we look at that, you can see I'm pulling a dependency injection from the kernel. I'm getting the kernel injected into my code base, and I'm getting the required service for chat completion, and I'm adding a message and getting the results back and returning that. So let's see what that looks like in our application. Again, this sample app, but I've got this chat. Now this chat doesn't really have history, and maybe we can start adding that on this call. And it definitely looks like I'm just getting a little bit of latency. So tell me about the speed of light. Now, something I added that I think is really nice when you're dealing with these OpenAI models is that sometimes it returns markdown. So give me and if you get just HTML or Markdown sent back to you, sometimes you want to render it. If I didn't have some code I'm going to show you, it wouldn't render this properly. And again, I don't really have history. If I asked it to tell me what it just told me, it doesn't have a history on the client side, so I haven't fully implemented that. But maybe we can do that in a second. But let's look at that rendering. So I do have this web app here. And so I've added into the web app some various components. You know, we have our weather component that was just doing that call to the weather, but we have a chat component, and it's a very basic for each message, display out who sent it. And I'll touch on that in a second. But we're just doing a send async. So when you type in a message and you hit the button, we're sending the message out and it gets the response. So ask the chat client to send that message and it gets a response back. We're not really persisting a lot of the history. We're not persisting that stuff, but we will as we play around with this. But in order to take that markdown and render it, I'm using a package called markdig. If I didn't want to do this, let's say I just want to return the raw text. It doesn't render the same way. So if I just did that and I did this and reran the application, what we'll get is something quite a bit different. Instead of nicely rendered bullet points and text, what we're going to end up with is raw markdown. And then once we're done with this, I'm going to show you one other little thing that I think will be really interesting, which is let's take this now and start deploying out to Azure. So here is our dashboard. And let's go to our application and chat. And let's see what happens when we're not rendering out our markdown the same way we were before. So you can see we've got markdown text for highlighting, and it's not rendering out the bullets the same way. So markdig is a great way to render that out. Now, let's say we want to take our application and deploy it to Azure. So I could do an AZD and init, and AZD and init will scan my code base and generate an Azure YAML for me, and it can deploy all my resources. You can see it deployed a new resource group, monitoring workstation, a container registry, my applications, my OpenAI, and then it listed out the endpoints that I can leverage to see these applications. And I can even go out to these resources running in Azure. Let me just show you them real quick and then we'll wrap up. So here's everything that got deployed. Just doing an AZD init and then an AZD up. It set up a managed identity and monitoring. It is deploying out my dashboard so that I can access everything. I had to authenticate to make sure I could access it. And yeah, there's my dashboard. So let's play around with .NET, play around with Aspire, and play around with OpenAI. And please check out all of the resources available. I want to thank everybody for the time today. I appreciate it.
Thanks, Chris. That was awesome. I see your chats about the quality. We're working on it. Just as a reminder, everything will be uploaded after the event. We are going to keep rolling, though, into Nalu Tripician's talk on Introduction to Cosmos DB and .NET Aspire. So let's have fun with that.
Hello, everyone. My name is Nalu Tripician, and I am a software engineer with Azure Cosmos DB here at Microsoft. Today, I'm going to be giving you guys a quick introduction to Cosmos DB and how to get started using .NET Aspire. As we all know, modern apps have complex data needs. Those can be combining data from multiple different data sources, such as events from different microservices or handling user input. It's also important that your database is able to change to your business requirements. That could cause a change in schema. Your database should be able to adapt without having any heavy changes to your application. And as your application scales, your database should be able to scale too, deliver consistent performance, ensuring that your database is not a bottleneck. If any of those sound like something that your application needs, then you might want to consider a NoSQL database, one of the many different data models that Azure Cosmos DB offers. NoSQL with Azure Cosmos DB is fast, flexible, and distributed. And it's enterprise ready for many different scenarios, from artificial intelligence to Internet of Things device telemetry. Some of our customers include the biggest retailers, gaming platforms, and financial institutions in the world, really showing that Cosmos DB is a super great option for any type of business. Some of the features that make Cosmos DB so great are its ability to scale. Cosmos DB offers infinite scale with zero downtime. Cosmos DB will scale horizontally by adding more physical partitions when your workload grows. This growth can either be coming from adding more data and needing additional partition to provision that data for, or by raising the request units, or RUs. RUs are Cosmos DB's measure of how much throughput a container can handle. You can have there are different provision throughput models, but essentially, if you need more throughput, all you have to do is raise the limit, and Cosmos DB will automatically, in the background, raise that limit with no downtime. As you scale, it's also important that you have consistent read and write performance. For point operations, it's consistent that even when you add more physical partitions, that your read and write performances are consistent. Cosmos DB will always know exactly where to route your request to, meaning that it can provide this consistent performance. Now, going back to RUs, for point reads for a 1 kilobyte doc, that will be about one request unit. Queries, on the other hand, might need a fan out across multiple physical partitions, which may impact which can impact your performance as you scale. However, through the SDK, you can tune these queries in order to mitigate this. So we talked about container scale, but Cosmos DB can also scale in a different way, globally. Cosmos DB easily allows you to add extra regions to your account with no data replication or sync management needed. All you have to do is go into the Azure portal, and with the click of a button, your Cosmos DB is now in a different region. You can add different regions as read regions for optimized read latency, or as read-write regions, which is super helpful for high availability scenarios. Cosmos DB also offers many other mission-critical services, such as security, analytics, Azure integrations, and much more. But right now, let's focus on scalability. Thinking about scalability can be daunting, and it's hard to anticipate your business needs in the future. But that's why Cosmos DB is built to scale with your business needs. One of the many ways to start small and scale up is with .NET Aspire, which we're going to go over later in the demo. The first way that I wanted to talk about, though, is with the local emulator. The local emulator is the easiest way to start up. You don't need an account, it's free and super easy to download, and just start testing some things out. The next way is with serverless. With serverless, you provision a real account, and this is great for dev or test workloads. Here, you only pay for the RUs that you use, rather than provisioning them up front. This is great for scenarios where you're developing during the week, but nothing's really going on the weekend. With serverless, however, there is no global distribution, and there are higher SLAs, but still a great way to start out. Another great way to start is with free provision throughput. With every account, with every subscription, you get one free account per subscription. This allows you to have the first 1,000 RUs and 25 gigabytes of data free for the lifetime of the account. This also does not limit on scale, and you can add as much data and scale globally as you need. This is a good way to allow for a low-cost startup. The final way is with autoscale. With standard provisioning, there are two ways to start an account: with manual and autoscale. With manual, you pick your throughput level, and that's it, until you decide to change it later in the portal. With autoscale, what you can do is set a maximum RU threshold And that way, Cosmos DB will automatically scale from 10% to 100% of that maximum. This is great for workloads with high variability. And the containers will automatically react without needing to change anything to be at the highest level, and go back down to the lowest when the traffic dies down. This allows you to have peaks and valleys. This is great for applications with peaks and valleys in your workload. It will react seamlessly with the traffic, and there's nothing that you have to configure apart from setting that maximum. Another great option is dynamic autoscale. With dynamic autoscale, each partition scales independently, where in traditional autoscale, like I just talked about, all the partitions scale up together in all the regions. Here, it's great because you only have to pay for the throughput that each individual partition uses. Now, we learned about some of the provision options and a little bit of an intro on Cosmos DB. But now you might be thinking, how do we get started? Well, there are various different data models with API access, but today we're going to be focusing on our NoSQL database offering and, of course, the .NET SDK. To add the .NET SDK to your project, just do .NET add package microsoft.azure.cosmos. Once you have the SDK installed, you'll be working through the logical resource model. That starts with the Cosmos client. This is the entryway to the account. With the Cosmos client, you're only going to use a single client for your entire application. This client is thread safe, it manages all the connection, and it keeps all the caches, like the address cache and the session token cache, and all other metadata wrapped up in a nice box. It's super smooth to use with no extra overhead. Once you have your Cosmos client, you can start connecting to your databases, which in turn holds your containers, and of course your containers hold your items. Now, there are two different connection modes that we have in Cosmos DB. There is gateway mode and direct mode. Gateway mode uses HTTPS to connect to a gateway node, which interacts with the backend. The backend is the physical partitions of the containers that you have. Direct mode, on the other hand, uses TCP to directly connect to the backend, skipping that extra backend op. This allows for lower latency. However, if you do have hundreds or thousands of partitions, this will open a lot of connections, so there are some trade-offs. However, we do recommend using direct mode for the lowest latency and best performance. With the use of Azure components, it's never been easier to quickly create an application using Cosmos DB. So that brings us to our demo. For our demo today, we're going to be looking at an application that is a dashboard managing Internet of Things devices. So let's first take a look quickly at our application right here. So as you can see, we have an Aspire application where we're adding Cosmos DB and we're adding our database. This is also going to be run using Docker containers. And we're also going to be using the emulator today, as it's the easiest way to start up and just show everyone how easy it is to develop with Cosmos DB and Aspire. So once we get this up and running, let's take a look at the dashboard. As you can see, we have our Cosmos resource, our API service, and our web front end. So let's take a look at this front end to see what's going on. You can see here that we have a few devices online already, but it's super easy to add another one, or even offline some of the devices. We can also delete these devices. Now, all this information is being stored in Cosmos DB. So let's take a quick look under the hood to see what's going on. So here inside of our application, we can see that we're creating a Cosmos client. Now, again, because our best practices include having a singleton client instance, this client is going to be using dependency injection to make sure that it's used throughout the app for everything that we need with Cosmos. Now, when we're setting up our Cosmos client, there are a few different Cosmos client options that we can have that will change the behavior of our application. The first of it, which is we can set our application name. So right now we have Cosmos Aspire, but we can name it anything we want if we want to add, let's say, demo to it. The next is we have custom serialization options. Now, there are a few built-in serialization options, such as having everything be camel case, or just the default, which is passing everything new normally. But you can also pass in any custom serialization options that you want. Another really important thing that we should go over is Cosmos OpenTelemetry in distributed tracing. Now, OpenTelemetry and distributed tracing is the best way to help debug your applications. So it's always important that we turn those on. And one other thing that we can see is that we have that we can control the connection mode, and we can easily switch between direct mode, which is the default, and gateway mode. Now, if you might have noticed earlier that I didn't actually press the delete in our application, that's because there might be a little bit of a bug that we can take advantage of seeing the power of OpenTelemetry and distributed tracing with to see how easy it is to debug. So first, let's try to delete an item. Nothing happens. So we should probably see what's going on. Going back to our Aspire dashboard, going into the traces, and we can see some of the calls that we have to Cosmos DB. Scrolling down, you can see these delete calls that are causing some errors. Let's take a quick deeper dive into it to see what's going on. So we see that we're having our delete item async call. We can see that we're using our OpenTelemetry. We can see that we're on gateway mode. We can see our machine ID, the type, and the status code. This is really important. So you can see that we have a 404 status code for the delete item async. We can also see our exception message, which we'll dive into really quick. So we can further see if there's anything that could help us debug this. So let's paste this in here and look into see what's happening. You can see that we have our system history. You can see our response status code does not indicate success with our 404 error. And we also have our activity ID, which can be helpful for tracing further errors that might be occurring with this specific call. Now, since we have a 404, that might be pointing us to something. Like I talked about, we have these custom serialization options that we're using, which right now we're using camel case. However, if we look at our delete item call, here you can see that we're passing something in called the partition key. This is how Cosmos DB intelligently routes its request. Now, the important thing to know about partition keys is that it is case sensitive. So with our serialization options, chasing it to camel case might not be the best option. So let's go back here, change camel case to default. And let's also, in the meantime, change it to direct mode. This is going to allow us to use the best practices that we talked about earlier and getting the best performance for our application. Okay, great. Now that we have everything debugged, let's say that we want to move to a live account. Now, with live accounts, it's really important that we, with global distribution, that we specify exactly what regions that we want our account to use and when. To do that, we can use something called the application preferred regions. That's another option inside of the client, Cosmos client options. So if you go into our Cosmos client options, and we have application preferred regions, we can create a new list that contains all of the regions that we have in our account. So let's say that we have a region in East US, and we also want to expand to West US. With application preferred regions, we can specify this list, and the SDK will know exactly what regions to route to. And if there's a case of an outage in the East US region, then we'll go to the West US region. Let's say that we want to expand even more. We can just easily go back into the client and create new options. Let's say if we want to create a new region in Central US. Easy, right? Now let's look further down into the item calls that we were talking about earlier. Now, it is also something that you can do in Cosmos DB is update the request options for each request. So let's say that we want to limit the items per page that we have to, let's say, 10. That's super easy to do. And when we're doing our query to look up all of our items, we can just set the max item count to 10 inside of our request options. There are various different request options that you can do, like I said, to help with tuning queries, or even to help route specific requests to certain regions. And they're super easy to change. Now, that's about all I have for you today. So before we end, I want to leave you guys with some extra resources. This first resource is another way to create a Cosmos DB account for free. It lets you try for 30 days with no sign-up, subscription, or credit card needed. I've also included some documentation that goes into a bit more further detail on how to start developing using the .NET SDK, as well as a link to the best practices that I was talking about earlier, which includes some other resources. I also have included the link to the demo that we used today. I want to thank you everyone so much for joining and hope you have a great rest of your day with .NET Aspire. Thanks. Bye.
Awesome. Very cool. Thank you so much. We are going to keep on plugging around with all of these crazy talks today. There are still so many to go. I hope you like my art expanding behind me. So just a reminder, check out the collection. It's got all the links you need for resources. You can see the source code for a lot of these demos. You can fill out the survey for this event and let us know what you think. You can do the Learn Challenge that lets you compete against other people also learning Aspire, which is pretty cool. But we're going to kick it right over to Jeff Fritz, C# Fritz, some of you may know him as, who builds a website called Aspireify. And he is going to show you how he built Aspireify by building and deploying with .NET Aspire on Azure.
Hey there, friends. Jeff Fritz here, and I am thrilled to be talking about the Azure Developers .NET Aspire Day about Aspireify, building and deploying with .NET Aspire on Azure. This is a website, this is a project that I've been tinkering with and building since about April, where we wanted to build a little website, a news hub that kept up to date with all the latest stuff that's going on with .NET Aspire, right? When you see code samples, announcements, videos, podcasts that either Microsoft folks or folks in the community are writing and producing, we wanted to be able to cover it and present that information in a unified way on a news website kind of thing. So we built the website aspireify.net, and there's what it looks like right there. You can take a look and browse through it. Go ahead to aspireify.net, and you'll see the current version of the site. I grabbed a screenshot just for this presentation, but it's got a collection of different things broken down into tutorials and sample code, videos and podcasts and announcements. You can find all there, and there's a great search functionality that you can use to go find maybe some of the topics, some of the techniques that you might be looking for to help you do more with .NET Aspire. But the key thing that was so important for us when I was building this website was I wanted it to be a website that was built with .NET Aspire about .NET Aspire. And what that does then is it drives me to start to learn and figure out how to do things correctly and in a real way that is supporting a live website, right? I want to be able to make changes, compile, check it into source code, do my continuous integration process, and finally deploy it out to the aspireify.net website and location out there on the big Microsoft Azure cloud. So I went through and I learned those processes, and we built those tools and techniques. Now, that meant I also got to explore and use a couple other Azure services along the way and integrating features that were appropriate in order to make this a complete website. So I added things like Azure Storage. I use Azure Tables to store information about the various articles that have been identified. I use Azure Blobs to store thumbnails from those articles so that I have something nice to present when you navigate to the website. And I use Azure Queues for communicating the arrival of new articles so that it knows to go generate a thumbnail and archive some information to present on the website. I built a service using the worker service template that would resize images. It's a little container app that just looks for new entries on an Azure queue and then resizes those thumbnails appropriately and saves them in Azure blobs. I also use Azure AI Search. I mentioned you can search for articles on the website, and why not just use Azure AI Search? There's a couple of indexes that are real easy to set up and configure so that it will read and automatically rebuild its index as I create new entries in my table of articles out there. And finally, I use, of course, Azure Cache for Redis. This is the service that's available on Azure. It runs Redis for you. So why not use that to output cache the articles, the web interface, as it gets updated, as new content arrives, so that we're not generating new HTML on every request, right? Let's drive down the amount of work that website is going to be doing. And if there's already content that's been built for a request, fetch it from the cache and present it immediately. This way we can conserve how much processor our web server uses and be able to handle a spike in traffic very, very easily. So let's take a quick look at some of the interesting bits of the source code for Aspireify.net and discuss some of the bits that we've created around our app host model, and take a look at a couple of the other things that are floating in there that you might find interesting. So a couple things that I set up and use in my Aspireify.net website's app host project, right? Here's my program CS for that, where we go and configure all the things that exist in the system that makes up the website. I set up, of course, my output cache using the add Redis statement here. However, as you can see on line 20, I publish it as a connection string out to Azure. And this is because, well, quite frankly, I'm cheap. So here's the deal. I already have an Azure Redis service out there running, and it stores and manages content for my blog. So it's already caching content for that, and it's not using a lot of space. So let's just share and use it here also, and then I'm serving two websites with one Redis cache. The alternative here might be to publish the Redis capabilities as a container. You can also specify to publish as Azure Redis. This is just fine for me to publish and reuse an existing service. Additionally, I use Azure Storage, and I mentioned that earlier. So here's where I configure the storage capabilities, and you can see I add Azure Storage, and I call it storage. But I set up some properties on that. I tell it to use a SKU that is standard LRS. That's local redundant storage. By default, .NET Aspire and the AZD tools will deploy and use a more robust storage mechanism and SKU out there. Well, I don't need quite that much redundancy for this website. I can get away with just local redundant storage. So I chose the less expensive and less fault tolerant version of Azure Storage to keep here. Now, that's some risk that I can take with this website. If for some reason that storage isn't available for a little bit, that's okay. It'll come back eventually and we'll be all right. I also tell it to run the storage locally as an emulator, and I specify with data volume, so it saves my local storage instance when we're running and debugging locally. Save that to disk, and I also specify use the latest version of the Azure Storage emulator. This way, there's no concerns with mismatching APIs as we're using the latest tools. And finally, I want to make sure that I call out here, I use a container that I named Storage Explorer that is made available by this person, Seba Gomez, on GitHub. And it's called the Azure Storage Explorer. This is really neat. All right, check this out. This is a Blazor-based application that serves as a storage explorer so that I can browse around inside of my blobs, tables, and queues out there inside the storage emulator. Because when the Azure storage emulator runs as part of .NET Aspire, it'll be deployed and have random IP ports assigned to it. Well, that makes it a little bit tricky to hook up the Storage Explorer tool. But with this tool, I'm able to point and say, here's the storage connection string, and pass in a connection string reference to the blobs, and it will find it and make sure that it connects to it directly. And I'll be able to have an extra line available inside my inside my .NET Aspire dashboard that has this Storage Explorer. And if I want to browse and look at what's in my local instance, I can just click through it there and investigate. And here's a feature that we don't talk too much about. I'm using exclude from manifest here. This is a method that will tell the .NET Aspire build, when you're getting ready to publish this, don't include this resource as something that's going to be published. It's only here to be used at developer runtime. All right. So when we're building and developing here locally. Really great stuff that makes it easier for me to navigate around and explore my storage. Last thing that I want to show you. I'm not a fan of magic strings. So what I did was I created a series of constants here for the various names of things that are saved and placed throughout my application system. This way, when my queue's name changes, or if my blob container's name changes, I've got the same constant that I've used throughout the application system to be able to reference and change that later in one place. I don't have to worry about setting up and having case sensitivity or misspellings that might happen out there. I've clearly got a constant that I can use as a reference, and the compiler will help me to ensure that I have the same reference to the names of my queues, the names of my blobs appropriately. All right, let's head back over to the slides and talk a little bit more about how this website system runs. So when I run the application, it comes up and we have a dashboard that looks like this. These are all the services that light up when I develop and run locally. All right, so I took a screenshot here so that I made sure everything was running properly and showed up in these slides for us. So you can see right up at the top, there's the blobs, queues, and tables running locally. I have an output cache container that runs locally as Redis. And after that, I have a little container that runs that manages a PDF engine so that I can generate reports. And then I've got some database capabilities with Postgres there so that when folks log in, I save their associated credentials into a little Postgres database on the side. And I also start up the PG admin service so I can browse into it. Next, there's that storage container and then the Storage Explorer, followed by the actual database server. Followed by the actual database that lives inside that database server, conveniently called security. And finally, I've got my C# projects that I've been building, a couple of worker services, my data migration service that migrates and generates all of the entity framework migrations. It applies those to the database as needed. My thumbnail generation service that I mentioned, a counter service that will do some statistical analysis and report on exactly how much traffic I get. And finally, my website down there at the bottom. So it's a nice collection of services and tools that make up the entire website system, right? It's a system of services and resources that make this up, not just a little website project out there. And this is important. This is something that I think as we think about building applications, we should really consider using .NET Aspire by default for everything, because as additional services come online, additional resources that you want to do, it's real easy to add and visualize them on a dashboard like this and to expand your system of capabilities using .NET Aspire versus trying to stitch things together after the fact. So very important capabilities and concepts that we need to understand as not just application developers, but system architects. So let me tell you about some of the Azure resources in use. This is the resource group that gets deployed and is running out there for Aspireify. This is just about everything except for my Azure Search resource and my Redis resource. Those two are shared and they're sitting just outside of this, but these are all the things that are sitting out there, including my own container registry, the couple container apps for those services that were built, a container apps environment that's going to manage all of those containers that are running as part of the application system, a key vault, log analytics workspace, some managed identity. There's my Postgres database, the storage account that contains all of the articles and blobs, the thumbnails that you see, and of course, the website down there at the bottom. Not bad, right? This is a pretty clear system and some things in there that you might not have expected that are part of your application system that you'll end up deploying at some point when you use all the features of .NET Aspire. Now, I had a lot of traffic come through the website a little bit earlier last week, and quite frankly, things like the Redis cache and the output caching strategies we have out there made sure that things just ran smoothly. Look at this, averaging about 6 microcores over the last week or so here. No problems asked. It's just running smoothly. It responds quickly, and I don't have to worry about any kind of spike in processor or memory utilization because it's just chugging along and doing its thing very quickly, getting articles, showing them, and then serving from cache. Now, everything that you hear about .NET Aspire and when we talk about deploying things, one of the best ways that we have for you to deploy your Aspire application to Azure is AZD. Now, AZD is the tool for getting your application system prepared and deployed to Azure. There's other tools out there that will help you get into Kubernetes, help you get onto AWS, but this is the tool that I use to deploy Aspireify.net to Azure. And it's real easy to use. There's just a few commands that you need to know in order to get your application running. AZD init, you run that at the command line, and it will initialize your application system, set up a couple configuration files after it looks at all the things that your Aspire app host has declared. AZD pipeline config will set up either GitHub Actions or Azure DevOps pipelines so that it can actually, build and deploy using one of those services. It'll also ask you for any input parameters that you need to provide that are secrets or things that you've declared that need to be added in, keyed in by hand. And finally, AZD up. Just take this thing and push it up, deploy it, send it out to the cloud, and let the magic happen at that point, right? Now, this is of course the way you do it with Azure. You can still build and deploy with your favorite tools and scripts and GitHub Actions that you're using right now, but using AZD really streamlines these things. Okay, it's not a requirement, but makes it a whole lot easier to do. But Aspireify.net isn't just that simple. It's actually a little bit more complex because we do have some things in there that are a little bit different. So what I had to do for a couple of things here, I had to actually hit the escape button, right? This is our way to jump in and add extra configuration that .NET Aspire doesn't have for us natively. And that's the AZD infrasynth command. So this command will generate a series of scripts, Bicep scripts, on disk that you can tinker with and adapt to meet your needs. Now, each time that I go and change the architecture, right? If I change the topology of my application in code, I'll need to regenerate this file. That's okay because I have it under source control and I can compare and apply my customizations easily every time I need to make an update. So you can see here, I made a couple changes to the default ingress capabilities. I added sticky sessions. I wanted to make sure that session affinity between containers was maintained because I'm using a little bit of Blazor Interactive Server. So I wanted to make sure that I stayed pinned to the container that I was working with. I also added my custom domains there. Right now, this isn't something that's easy to do with AZD or in our C# code for the app host project, right? So I have custom domains set up there that will automatically deploy and update the Aspireify.net and www.aspireify.net domain names. Makes sense. They're declared there. It knows how to allocate them, and it will allocate them appropriately to the Azure Container app that hosts the website. Additionally, we had to customize the GitHub Actions a little bit. So I do a few other things when the website builds, right? Among them, I capture the GitHub SHA, the Git SHA, right? That hash that uniquely identifies what was built. This way, when somebody sends me a screenshot of something, or if I want to check which version is currently deployed and running, I have the SHA, the current version out there. It's embedded in the footer, and you can see a snapshot of the footer from when I wrote these slides a couple days ago. You can see a snapshot of the footer down there, and I list version hash, okay? If you browse to the website right now, you probably see a different version hash there on the bottom. I also report the current .NET version that it's running under, the current Aspire version, and when the page was last rendered. And capturing and identifying the most recent Aspire version is right there at the top of my GitHub action. I have a little project that just browses through the current versions of the Aspire packages and grabs that version and reports it inside of a file so that we can analyze and report that on screen there. I also have unit tests. Darn it, who doesn't run unit tests as part of their project? Well, I do, and I wanted to make sure that my unit tests ran and got reported before anything was deployed out to Azure. So I added these two sections that you see there, test with .NET, and then publish test results using this action called publish unit test result action. Real easy to use. I encourage you to check that out because it generates a nice little report and will send you emails if the number of unit tests that succeed or fail or the duration that they took changes significantly. Very handy to have that information and to know when there's a significant change there so that you can investigate and follow up on exactly what might have happened with your application. Now, some of the things that I've learned since building and deploying with .NET Aspire, I have my app host project set up with sliding versions for all of my integrations that I use with .NET Aspire. So this way, when my tables or blobs or Postgres, when any of these integrations have updates, maybe there's a patch because there's a new version of the underlying container, the underlying capabilities, maybe there's a security patch that it's important for me to receive. I put in sliding version numbers here, 8.star. You see that for most of those packages there. It's important to have that there then so that I can just push a build and it'll automatically grab the latest versions of those integrations and deploy them with the Aspireify.net system out to my production workspace. However, with .NET Aspire 8.2, that app host project, that package down there on the last line, it must be hard-coded to 8.2.0. And that's a known issue that the team is fixing for a future release. Additionally, I've learned to revisit and enjoy regions. I've got regions in my code for that app host file because it makes it real easy for me to see the different sections of my code that are setting up different resources. By having these all collapsed, I know here's exactly what's being set up in this region. I can go through and find it very quickly instead of having to see this massive file that has all this configuration code for all of these different resources. It's great to have all the resource definition in one location. However, it gets to be a lot for my human eyes to be able to consume all at once. So to be able to hide that and reduce the number of concepts that I'm looking at on screen to just those things that help to facilitate my database migration service or my security database and just look at that one block, makes it a lot easier for me to consume and work with my application system. I got to tell you about Azure AI Search. I was pleasantly surprised at how much I was able to get out of this service and integrate it with .NET Aspire. So Azure AI Search is available for you out there. There's a free instance that will support indexes up to 50 megabytes in storage. That sounds like not a lot, but here's the thing. Aspireify.net has about 220, 230 articles right now, and each one of those has a paragraph or two description that you can search. So I put all of that content into my search index, and it only takes up 320K. 320K. So I've got plenty of room to expand and grow before I'm going to start seeing any kind of pressure on need to upgrade from the free SKU here. Additionally, configuring Azure AI Search was real easy to do inside of my app host program, but really all it's doing is passing along an app ID and an API key. It was actually a little bit easier to pass those along as parameters into my web application. You can use the Azure AI Search integration, but you get the exact same features if you just pass in the API key. The monitoring that takes place to give you the tracing and logging with OpenTelemetry works the exact same way, whether you're using the Azure AI library directly in your application or if you're using the integration. So I don't really feel committed to using it just yet. I think there's new features that the team needs to bring forward before we start looking at and saying, yes, I want to use that integration inside my system. But you can still use the exact same way you code against Azure AI Search today. I want to make sure that you know that when it builds containers, when AZD builds containers, when that AZD up command is executed, it's going to put them in your registry for you. And you're going to get a lot of containers in your registry. Here's a snapshot of my registry that I took a couple days ago. And there's a lot of instances and copies of this same container out there. Going back as early as August 13th, you can see on here, right? And we're here in the middle of September. That's a lot of extra containers that it's not using. While it's nice to have them out there and I can roll back and choose a different version, realistically, I'm not going to go back to a previous version before 2 or 3 versions ago. So I encourage you to check out, there's a PowerShell script that's available out there on Microsoft Learn. Check that out, download it, and it will help you prune this collection of containers that is generated and stored inside of your container registry. There's even some folks that have that PowerShell script run once a week, run once a day, depending on how frequently you're deploying these. What you need to remember is that you get 10 gig of storage by default in that Azure container registry. And if you run out of space, it won't deploy anymore. You'll just get errors in your script, okay? So make sure that you maintain and clean out some of these older container images out here. I do it once every couple of weeks because I don't deploy very frequently and I don't deploy many containers. So it's about time for me to go through and run that script again and clean up over here. All right. That'll help extend the duration that you're able to use that same initial SKU of Azure Container Registry. All right. That's all I have about Aspireify.net, some of the lessons that I've learned and how we build and deploy that. Real easy to do. I can't share any of the source code for the website, but happy to publish and share some of those screenshots for you so you can see some of the source code modifications that were important for me to make in order to get the application deployed. It's an amazing event today. Thank you so much to the organizers for inviting me to talk about our website. I want to make sure you catch up with all the resources from the event. Check it out at aka.ms Azure Developers .NET Aspire Day/collection, or take a picture of that QR code. It's going to take you to the same place, and you'll be able to catch all the resources right there on your device. All right. Thanks so much for watching. My name is Jeff Fritz. I hope you have a fantastic rest of your day.
Thanks, Jeff. That was a wonderful summary of Aspireifying, building and deploying with Aspire on Azure. Aspireify.net is a great website. It's out there, so you can all look at it today, and it posts blogs and all that kind of stuff and videos for Aspire content. So we use it all the time internally, and it's cool that it's built with Aspire and that it's built by Jeff. Okay, quick break for some housekeeping. That's what I'm here for. First of all, keep your questions coming in the chat. I'll try and answer them as I get a minute. Definitely happy to answer things that I know the answer to, or point you to where you can hopefully find answers if I don't. Just a reminder, this event is being recorded. It will be available on demand shortly after. So, if you're having issues with stream quality, you can come back and watch it. You can also, as Jeff said, go to that collection and see all of the, the links and the projects and the resources and blah, 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 blah for this event. There's a lot of those quotas there, open source. There's some of the Learn modules. There is, of course, the Learn challenge, where you can race against people. I'm not describing it well, but it is very fun. You get badges. You win if you learn, which is very cool. And then, of course, our event survey. So that is the way to tell us, if you like this event, if you like this content, if it's too deep, if it's not deep enough. And what you'd like to see more of, especially as we come into .NET Conf in a couple months. So all of those links, our wonderful production team, thank you, Jamie and Katie and John in the back, are popping up, and they're putting them in the chat, and we'll keep those rolling, and I'll keep saying it throughout the day. But next we're going to talk to Catherine Wang, and she is doing an introduction to Azure Redis Cache and .NET Aspire. So let's see how this goes.
Hello, everyone. Welcome to the session for Azure Redis and .NET Aspire. I'm Catherine, a product manager in the Azure Redis team. Assuming you watched the earlier sessions on .NET Aspire fundamentals, we will focus on Azure Redis integrations. We'll go through the scenarios for using Azure Redis with your .NET Aspire application, and we will have two demos, one on the Azure Redis output cache. The other one will be a real-time leaderboard with active geo-replication using Azure Cache for Redis Enterprise. What are the scenarios for using Azure Redis with your .NET Aspire application? Redis is an in-memory key value store that's traditionally used for caching scenarios. This includes output cache, distributed cache, session, and so on. So we use Azure Redis to improve the performance of your application and store the volatile data. The advantage for using Azure Redis versus improper caching is that an external cache store would provide you the resiliency during server failover event. And in case of scaling out your hosting servers, having an external cache will also provide the consistency on data, and it will not consume any of your application servers' memory and CPU resource. Azure Redis is also used widely as a real-time streaming platform. A classic scenario is Leaderboard, which is widely used for gaming applications and finance, e-commerce, and so on. Azure Cache for Redis Enterprise would provide active geo-replication for your globally distributed microservice app. And this will also get you the 5.9 SLA with active geo-replication. Another common scenario for using Redis is message brokers. In microservice architecture, you want to get the scalability and the service responsibility segregation, so Redis can be a message broker to decouple your front end and back end, and the communication can be done through the Redis message broker. And for Azure Cache for Redis Enterprise, We also provide modules for advanced usages, such as the vector similarity search that's commonly used for intelligent applications that comes with the Redis search module. Redis.json provides you a good NoSQL data store. Redis Bloom and Redis time series are used commonly in IoT applications. Let's look at our first demo application using Azure Redis for output caching. For the architecture diagram, we will look at a .NET Aspire application hosted by Azure Container Apps, talking to Redis for caching the web front-end web page output. And Azure is a secure cloud, so we will use Entra ID and Key Vault to back up the service-to-service communication or any potential secrets, and continuous monitoring with Azure Monitor services. This is our Azure Redis version of the Aspire application that use output cache. All my project code is basically scaffolded from the project new create experience. You just have to use that Redis checkbox for adding Redis as a service reference and having this code in your app host program.cs file. In order to use Azure Redis, you add this .publish as Azure Redis line to your service reference. And that's all you have to do to get started. Let's look at our application in Azure. Here, navigating to my resource group, that's hosting my Aspire Redis application. Just so you know, we are really using Azure Cache for Redis instance, and this is done from the Azure Developer CLI azd app command. If we go to the web frontend, go to the weather page. As we refresh, you can see the numbers don't change for a while. This is because everything is cached in the Redis instance. If we go to the Redis instance itself, we can verify that the page has been cached. This console enables me to use Azure Redis or Redis CLI with the Azure Cache for Redis instance, and this is the cached record. Our next demo is on the active georeplication powering a real-time leaderboard. So for a globally distributed application, you want to deploy multiple instances of your app closer to where the customers are in order to reduce the network latency. So suppose you are a gaming application, you deploy one instance in Central US and then another instance in East US. Players in each region should be able to see the same game leaderboard. So if you store your leaderboard data in Azure Cache for Redis instance, somehow this data needs to be in sync. And that is where the active georeplication comes from. A lot of other data services would do georeplication with one active and one passive replica, meaning read-only replica. But in our case, Azure Cache for Redis Enterprise provides read and write capabilities to all replicas configured in one georeplication group. Let's take a look at the code. So in the same program.cs file of the app host project, I'm specifying publish Redis as connection string. So during publish, I can pass in the credentials for connecting to an existing pre-configured active georeplication infrastructure. That is one way to make sure you can configure your infrastructure separately and reuse it for any of the application. And all the passwords are dealt securely, masked and stored in Key Vault. I'm also adding cache, Redis cache as a reference to the API service project and the web frontend project, so I can refer to this Redis instance in both places. Starting with the API service. Notice in the program.cs file, I'm adding Redis client with a reference to the earlier configured Redis instance. So this allows me to obtain a connection multiplexer object during the service startup. And from this point on, I can continue with the normal Stack Exchange Redis library and reuse the code for leaderboard. I have two methods here. The map get allows my frontend to read the leaderboard, and the map post would allow my web frontend to write into the leaderboard with the player's name and associated score. And in my web application, I created one more API client class to allow these APIs to be used with my Blazor frontend component. Here's the code for calling these APIs. Now, let's take a look at this in Azure. You see, I have two Aspire projects deployed to my container apps in two different resource groups, one in the central US region and the other one in the East US region. And I'll show you the two instances of the Redis cache. This is my central US instance of the Redis cache. And if I go to the active georeplication setting, you can see it's linked with another instance from East US. Now let's see how this works. So I have two instances of my container app hosting the .NET Aspire application, one in the East US, the other in the Central US, connected to two instances each of the Azure Redis Enterprise instances. So if I continue to play game here, this is the East US instance. I enter player name, say play game. You see my leaderboard is updated here. And for the other region, if I'm a player entering this, refreshing the page, I can see the same leaderboard information as the previous one. And just to show the active aspect, I can write to both Redis cache. If I update the leaderboard here, on the other one refresh, I see the same information. So you get all these advantages for using the Azure Cache for Redis Enterprise with active georeplication to power your real-time streaming, globally distributed .NET Aspire applications. For all the concepts and the sample code, you can find them in the link here. And thank you so much for watching.
Thank you, Catherine. That was great. Redis is like the first thing we always demo when we show Aspire because it's cool and it's easy and you don't realize you need it until you need it. So that was a really great deep dive into that because I always just breeze by it. Reminder for everybody, there is the collection links. Catherine just shared all of the links for her source code and material as well. The collection also has the link to the survey. It has the link to the Learn Challenge. And of course, some of the other sample code we've seen so far today. But we are going to keep on chugging. Up next, we have Jerry Nixon, who works on SQL. And if you have ever, used the cloud or an app, you've probably used a database, which is pretty cool. And so SQL is a great option, and Jerry is kind of our SQL expert. So we're going to have him introduce us to SQL Server and .NET Aspire and how we can use them together. So take it away, Jerry.
How do you work with a SQL Server and a .NET Aspire solution? Well, this is how. But there's a lot more to it, so let me explain. In this session, we'll introduce Azure SQL Database and how to use it with .NET Aspire. What is Azure SQL Database? That's a great question. Azure SQL Database is SQL Server that runs in the cloud. It is the PaaS solution for SQL Server with more than 250,000 active customers right now. That translates to nearly 10 million active databases and 70 trillion queries. 70 trillion queries a month is more like 27,000 simultaneous queries every millisecond. When it comes to capacity and the ability to deliver, Azure SQL Database is unbelievable. 61 petabytes of storage are currently in Azure SQL Database. That's around 25 million copies of Doom. Remember Doom from 1993? Well, let's start with the basics, right? So we have nothing going on, and let's start introducing SQL Server the best way that we can. We'll start with SQL Server as a connection string. That means we don't actually introduce SQL Server because we already have SQL Server in our development environment. You're already running it on your local machine. You're already running it in a local container. You're already running it in a local network. Maybe you're even running it in Azure. Great. So now we can say SQL Server is actually represented as just the connection string. And because I'm saying add connection string, I can go into my secrets and I can make sure that SQL Server is there. It will pull it out and pass the reference to all my different applications that are hosted inside my solution. That's where a lot of developers are today. And this is actually where a lot of developers might start. But there's a lot of value when it comes to a repeatable, reliable, and prescriptive development environment. So let's talk about what Aspire can give us when it comes to SQL Server and Azure SQL Database. If you're wanting to add SQL Server, the easiest way is to just use .add SQL Server and give it a name. When you do that, that's instructing Aspire to go and pull down the latest copy of SQL Server that runs in a container. SQL Server runs on Linux, and so it's a Linux container, and it runs inside a container. It'll pull down the latest for you, and it'll name that container something along the lines of my-server. And then you can say, let's add the database to it. So now I'm going to add a database inside SQL Server. Remember, SQL Server is a container of multiple databases. This is indicating that the database you're going to use is called my-db. What it builds for you then is the database at 12.0.0.1, and then it puts it at some specific port, and then the initial catalog is going to be my-db. That's the syntax in the connection string. Now, what you need to know is that this doesn't create the database. It does create the server, but it expects that the database is going to be there, and it's going to be called my-db. That means if you run this command, go then to this server through some sort of management tool like SSMS, Visual Studio, Azure Data Studio, or whatever it is that you use, you'll find the server there, but you won't find the database. That's because add database is really an instruction at the Aspire level to create the initial connection string. And that's it. What happens then when I run that command? Well, it's beautiful, right? It creates two pieces inside the dashboard, right? I see both the database and the server. And you can see the source then is the latest for SQL 2022. And if you go over to Docker, you can see that there is now a my-server that is running inside Docker, because that's the way Aspire works. And so it's nice to be able to see what's actually happening. But there's a lot more we can do than just this. Once we have the database running, now remember, the server is running. We don't have a database. We'll get to that in just a minute. But how would we use it if this is all we needed? Well, we can say add projects like you would add any project to Aspire. And then we can indicate with reference. And basically, with reference to SQL Server says, go and get my connection string. Now, service discovery inside Aspire then can go and get that from the environment. It'll automatically be set. You could read it, I suppose, in the raw, but you can also use service discovery. That's nice. Another thing you might do is you might say in the development environment, it's one way, but in the production environment, it's another. So you could use is publish mode. In publish mode allows me to have a Boolean. This is a ternary operator where I say, if it is publish mode, then go ahead and use just the connection string. And then if I'm in my development environment, you can see it's just builder.addServer, add database like we had before. So now you can have multiple types of operations depending on the environment that this is running in. Now you might write something far more sophisticated than I have here in just this slide, but it's nice to know that you can switch your operations depending on the production state. I've already got the basics kind of behind me. Let's go through some more advanced features and let's step through them one by one together. And let's begin with how we get that data into SQL Server. With bind mount allows me to take an external folder or file and map it inside my container. So with bind mount in this case says I'm going to a local folder called /script. So this would be a subfolder of the app host. If I'm running this in the app host, of course I am. And then the target then is user/config. That's a known location inside the container that I'm going to. And then I can, again, do another bind mount for /SQL. That's where the SQL scripts will be housed that are going to run at the beginning to create my schema, create any kind of seed data or anything like that as well. This is where it's going to go into the target. And then finally, I will update the entry point to point to a shell script that I'm going to use. So this is nice. It's a lot of steps, right? It's 1, 2, 3 things I get to add, as well as provide the script and provide the SQL. But now I have the ability to create that database and create the seed data that I might want for my development environment. Beautiful. Now, what if every time I debug, I don't want to run that again and again? I want to have it so that the operations that I'm doing stay inside my database. I want persistence across debug sessions. So I can say with data volume, and if I go back to Docker desktop, I can see that calling it my data volume just creates a data volume inside Docker for me and then mounts that automatically into my container. That's beautiful because that data volume then is going to hold all of the database master files and log files so that everything is stored and persistent across my debug sessions. That's nice. All right, what else can I do? Well, another thing I can do is I could say, when you create that database, use this password. And the reason I might do that is because I might have tooling that points to the database and expects the container, if it's running, to just be accessible. So I have a persistent known SA password. That's really nice. And then the way this works inside Aspire is I just use manage user secrets in the app host, and then I can start editing that JSON file. Now, I want to point out that at the top is the parameters called SQL Server password, just like we said. And I have PASSWORD as my default persistent SA password, right? That's really nice. But what's this line below it? The line below it is the my server password that was created before I did this, right? Because I called it my server. And so the server already had an SA, it needed a password, it generated it, and it stored it here. So the truth is I have a persistent password, it just wasn't a known password. So I could use the syntax that I showed a second ago, or I could come in here and just change the auto-generated password to one that I prefer. It's really up to you. And then We just pass it in when we add the server. But there's something else that we can do. We can also influence the port. Influencing the port makes it even easier for me to go in and interact with it from tooling. So now SSMS, ADS, or whatever it is you're using to interact with SQL Server knows the name of the server, which is just local, and then it knows the port that it's going to, it knows the password, and it knows the database name. So now it's nice and easy for you to work with it both programmatically inside your code as well as using some database tooling. That part's really nice and almost an important thing to maintain your sanity. So now back to the dashboard for Aspire, you can see it's running, and you can see on the right that the endpoint says it's running on TCP localhost, which is what you would expect, and that 1234 is the port. The next thing to do is maybe you're building this out as a container, you want all of these features to be there, but when you're done, all you really want to do is publish it just as a connection string. So that's really nice for me to be able to look at this and say, I'm going to dial down a little bit of the complexity when it comes to publish time. The next thing to consider now, some of the things that we're going to see very soon in version 9, especially things that are relevant to SQL Server. So let me just start with one of the biggest and most important one is going to be publish as Azure SQL database. Take the configuration inside Aspire and hand that off to Azure to create the Azure database that we want. Now, this doesn't exist yet. Well, it does exist. It's just experimental code. And so that's the reason I'm showing you the pragma syntax above it, because you'll get at least a warning when you start to use this saying that it's experimental code. Now, the downside of using experimental code is that the syntax could change. So we're really early on to be able to see what it's going to look like to be able to take the database that you've configured inside Aspire and push it into Azure. But this gives you a starting point to be able to see where you're going, as well as to be able to comment back as a community member to influence the direction of the publish process. So can we take Aspire and publish by database up into Azure SQL database? Yes, we can. And this is how we would do it. What's the long term? This may very well be it if it proves to be sufficient. So what is it doing behind the scenes? ARM is Azure Resource Manager. That's the way we would script our infrastructure. And on top of that is another syntax called Bicep, which simplifies it. You can think of it as a TypeScript for JSON. That's Bicep for ARM. Okay, this is one of the things that you could do. What else can I do? This is really nice. Now I can say that I want to create the local container when I debug. And I know that it's going to take a few seconds for SQL to spin up. And I know it's going to take a few seconds for SQL to run my SQL script and create my database and seed my database. Beautiful. Now, what I really want is to make sure that the next time I debug, I don't have to go through that same amount of time. And that is what with container lifetime will give me, basically saying, create this container and don't create it again. Just leave it. So if I stop debugging, please don't tear it down, right? So that's really nice to have this persistence across debug sessions. Another thing I can do is now tell my application that consumes my database to wait for it. So what happens if I am waiting for the SQL Server to load and I am waiting for the SQL data to be seeded? Well, it could mean that my clients in my debug session are already running, expecting it to be there, and I'm getting errors when I really shouldn't have errors because all I'm really need to do is wait for that database to be there. There are already libraries, we'll say temporary out-of-band libraries that are out there for you to be able to use. Great, you can do that. Just know that as we move forward into Aspire version 9, they've already previewed these capabilities coming through the main channel. So that's really nice to see this coming. It's going to really help us as we start doing sophisticated things with products like SQL and Azure SQL. So that's really great. Finally, this is just a little piece of candy that's coming from the community, and that is to be able to point to a database project. So if you're using a SQL project, then you can point to that project that already has all of the DDL or the create scripts to build out the schema of your application and perhaps even seed the data. That then compiles into what we call a DACPAC, D-A-C-P-A-C. And so now I can use this other library, which is msbuild.stk.sqlproj.aspire. And that is the preview library you can use today to go ahead and add your SQL project and from its DACPAC, publish the SQL server. So that's a lot of power if you think about it. A really nice contribution from the community to be able to kind of meet where lots of developers are, especially we have code first developers, but then we have database first developers. This is the database first approach being met. Okay, there's a lot coming down the line. And one of the things that I want to make sure that you at least know is in addition to SQL Server, a perfect companion to it is the Data API Builder, also fully now supported inside Aspire as a container. We'll certainly see the componentization of Data API Builder coming. But in the meantime, look, you can just treat it like a standard MCR container. You can bind the config file itself, right? The same way that we bound the SQL file above, and give it a reference then to SQL Server. What's beautiful about that is that now you have SQL Server, now you have data inside your SQL Server, and now you have a data API on top of it. A REST API, a GraphQL API, whichever you want, because Data API Builder supports them both. So how much do we see Aspire and SQL Server as friends? Completely. And advanced developers out there already using SQL Server, wondering what are the pieces that connect them together? These are the ones. If you want more information, you can go to aka.ms/dab/aspire. It has all of the samples that I just showed, as well as a working sample to get Data API Builder working with it as well. All right. My name is Jerry Nixon, and best of luck with your Aspire adventures.
Thank you so much, Jerry. That was a great introduction to SQL Server and .NET Aspire. It's amazing how much information you can get across in like 15 minutes. And hopefully the quality is better for you folks who are hanging out with us live. Feel free to let us know in the chat. We're tweaking settings in the background. We have an amazing team kind of handling this while I just sit here and draw on the whiteboard. Lots of fun. So Jerry showed the links for the collections. I'll say them again, and they'll go in the chat again. Please fill out the survey. Please do the Learn challenge and all of the fun stuff, and check out the code. We are going to roll right into the next one, which is Maddy McCleary, and he's going to show us an introduction to Azure Monitor and .NET Aspire.
Hey folks, it's great to be here with you. I'm Matt, a product manager on the Azure Monitor team. I've worked in the data and analytics space for 10 years and 8 of that in monitoring. I'll be sharing about Azure Monitor and how to transition from .NET Aspire to Azure Monitor. Today I'll cover a few questions. Why production monitoring? How do I enable Azure Monitor? And how do I transition from .NET Aspire Viewer to Azure Monitor? First, why production monitoring? The .NET Aspire Viewer is great in the development cycle. It enables rapid iteration and troubleshooting at no additional cost. But when you are running a high availability and scalable service, your monitoring solution needs to be highly available and scalable too. That describes Azure Monitor. What I've listed are a set of distinctives of production-grade observability that are included in Azure Monitor. Secure data storage and query layer, alerting engine, not just the application layer. It includes Infra 2, flexible dashboarding, applying policy at scale, advanced diagnostics, where we reason over your data, extensive integrations with Slack, ServiceNow, Grafana, and more. When I think of Azure Monitor and what makes it production grade, the first thing I think of is the platform. On the right is a depiction of Azure Monitor. On the left is the data we collect using SDKs and agents, standardizing on OpenTelemetry. The purple square on the right is application insights, curated experiences I will cover in a few minutes. In the middle, and what sits at the foundation of all the experiences in Azure Monitor, is the data platform. We can distill it down to 2 components. Log Analytics, our logs and traces platform, built on the same technology that powers Azure Data Explorer, and the Azure Monitor Workspace, Azure Monitor's next generation time series metrics store. Together, these provide the reliability, scale, and security that is required for modern distributed applications. Log Analytics recently announced a new log storage tier so you can better optimize your costs and select the best storage tier that fits your needs. And Azure Monitor Workspace is absorbing more workloads within Azure Monitor, and it's built to interop with PromQL and Grafana and supports exponential histograms. With that brief overview of production monitoring, let's move on to how to enable Azure Monitor. As I mentioned earlier, it's a combination of agents and SDKs for the full experience. However, I'm going to focus on how to collect data in the application layer. There are 2 paths to enablement: auto instrumentation and manual instrumentation. When you are running on an Azure resource that supports auto instrumentation, this is the easiest way to get started. You simply turn it on in Azure Portal or apply it via policy. We inject the API and SDK to collect the data that powers Azure Monitor Application Insights. If you're running on a service that does not support auto instrumentation or wish to have more control or write custom code against the OpenTelemetry API, you can use manual instrumentation. The Azure Monitor OpenTelemetry distro is a single package that bundles the OpenTelemetry metrics, tracing, and logging SDKs with popular instrumentation libraries and the Azure Monitor exporter to offer a first-class OpenTelemetry-based experience on Azure Monitor. And of course, it's extensible, so you can add additional open source components, such as processors and instrumentation libraries. When it comes to languages where we do not offer a distro, such as Go, Rust, or Ruby, we're building out the infrastructure to support the ingestion of native OpenTelemetry protocol, often referred to as OTLP. What Bubbles 2 and 3 show is that we are investing in a path to ingest native OTLP first to Azure Monitor Agent and eventually via a cloud ingestion endpoint. You can read more about this vision in a blog linked in the QR code. Bubble number 1 shows what is available today. As the image shows, the Azure Monitor OpenTelemetry distro is a thin wrapper around the OpenTelemetry SDK. This slide shows the step-by-step of how to take the eShop Aspire demo and use the Azure Monitor OpenTelemetry distro to enable Azure Monitor Application Insights. I'll show you this in Visual Studio. All right, so I have downloaded the eShop demo, and you're welcome to download it as well and follow along the QR code. And when I pull up the eShop demo, there's a few changes I've made to it to add Azure Monitor. The Aspire viewer is added by default, and then to add Azure Monitor, I first downloaded the Azure.Monitor OpenTelemetry.ASP.NET Core package, which is what we call the distro. This was added to, I apologize, this is a bit hard to see here. This is added to the service defaults dependencies. And this ensures that it is added across all the services in eShop. You can see it's been referenced right there. And then I also moved over to the extensions in the service defaults and added my single line of code that initializes the OpenTelemetry distro. Wrapped it in an if statement in case the connection string's not found. And then finally, I added my connection string to my secrets. secrets.json. And I was able to get to my secrets by right-clicking on app host and heading down to manage user secrets. Where I found my connection string was in Azure, where I created an application insights resource. So what I was able to do here is in Azure portal, in the search, just look for application insights, click on application insights and follow the prompts to create a resource. It takes a few steps. And then when the resource is created, you're able to find your connection string listed right here. And finally, I went to my program CS file under eShop app host and added a reference to my connection string and also referenced my connection string in each of the 10 services that are spun up in the containers of eShop. Okay, so with that, let's run the application. Okay, now we have eShop running, and it also spun up the Aspire dashboard. And then separately, we also have application insights running as well. So we can go to a view called Live Metrics, and we're able to see in near, let me make this a little bit bigger. You can see in near real time our flow of metrics coming off the application. And the first thing I wanted to share is that if you go to structured logging in the Aspire viewer, and you also hop over to a sample telemetry stream in Live Metrics, you can see that what we're looking at is the same events. It's the same events coming off the Aspire viewer and flowing into application insights. So if you're familiar with the Aspire viewer, you can easily transition over to looking at a very similar thing in the Live Metrics view within application insights. And similarly to the Aspire viewer, we also have the metrics here, and then one additional feature we have in Live Metrics is the ability to filter down to the specific telemetry stream that you'd like to see. So if you, for example, only want to see your exceptions, you can filter down to just see your exceptions. Okay, so now that you've seen the similarities between the .NET Aspire viewer and Live Metrics, I want to zoom in a bit more to application insights to show you what's available in production monitoring. So let's zoom in here and hop out of Live Metrics and show you the investigative tools that are available to you. First thing I want to show is a tool called Smart Detections. Actually, before we get there, what I want to show you is Application Map. Application Map shows you a topographical view of your application. So you're able to see all of your services, how they call out to dependencies. We call these lines edges. And so when you see red, that indicates that there's an issue that you can drill into further. We also have something called Intelligent View in Application Insights, where if you enable Intelligent View, it's able to cut the noise out of the edges. And if errors are transient or short-lived, they'll disappear, and your noise to signal ratio will improve. So now we will go to an application with a bit more telemetry and show you Smart Detections. Smart Detections found all on its own without me doing anything. Just looking at my telemetry, it detected a failure anomaly in a dependency, and it gives me information about that dependency, tells me what it was calling out to, what the result code was, and for each of these operations that are issues, I'm able to drill into the telemetry further by following the links. The other view in Application Insights that's useful and that I want to show you is a performance view. Performance view is a powerful view, and I apologize if this is a bit small, but you're able to see the latency of requests for performance tuning. And for instance, you could drill into your 95th percentile and find issues where, for instance, a time range where your app is experiencing issues. This arrow indicates a deployment. So perhaps it's after a deployment, and now we're seeing a spike in latency of requests. You're able to zoom into that, and right away, it will bring right to the surface what operation, and this represents a distributed transaction, is causing issues in your application. And by drilling in further, we're able to see right away what some of the common properties of this transaction are, where it's seeing the issues, and what Chicago. That's interesting. 56% of the requests are from Chicago. You're able to see more information about this particular issue, and then drill into individual samples of the requests. So, by drilling down further, we're able to see that interestingly, this one was actually generated by a synthetic test, which Application Insights offers. And then we're able to see the trace through including the calls out to the SQL database, a couple of retries, and the exceptions themselves. And then for this particular exception, we're able to see how the exception message, the type, even the failed method. And at this point, you can either create a work item or you can go to your specific line of code and make a fix. And then, you can actually even take this a step further. And when you're dealing with real users, or you want more of the perspective of a real user, we're able to hop over to some additional linked telemetry, for instance, which the user flows experience, which is able to show all of the steps before and after the failure. And these are all adjustable. You can add additional steps here. And this user flow is very flexible. You can use this to see how users are traversing throughout your application, and learn where they're hitting dead ends. And so this is just a small sample of the real user monitoring available in Application Insights. There's one final thing I just wanted to share before we're at time, and that is within the performance view, we've recently introduced a new feature called code optimizations, and this feature reasons over your data and particularly your code in your application to make suggestions on how to optimize your code for improved memory and CPU usage. So, for instance, here's an example of an optimization where it says a particular method is causing unusually high memory, and then it gives a suggestion on how to improve it. This is pretty powerful, and it really just is an example of how we're trying to bring insights directly to you. All right, so with that, I shared a bit about how .NET Aspire Viewer is similar to the live metrics view in Application Insights, and you can transition from one to the other fairly easily. And I shared how Application Insights has live metrics, and that's very similar to the metrics that you see in the .NET Aspire Viewer as well. And lastly, I shared a bit about the diagnostic views in Application Insights. First, the application map, which shows a topographical view of your application and helps and shows the dependencies and wherever you're seeing red there's issues where you can drill in further. And then I showed the performance view, how you can optimize your application, both the code as part of Code Optimizer and also slow calls as well out to dependencies. All right, everything I showed you today is all publicly documented. And so this is a reference to documentation. And lastly, if you're having issues or you're running into need some advice or you're running into a blocker, feel free to reach out to me directly. My email is otel@microsoft.com. Those emails will just go directly to me. Thank you so much. And it's been fun to be here today with you.
No, thank you, Matt. That was awesome. That was a great introduction to Azure Monitor and .NET Aspire. Azure Monitor is an awesome tool. So Always love getting a deep dive on that. We're going to keep going, try to stay on track with David Pine, who writes almost all of our amazing .NET Aspire documentation. He is a beast. We love him. And he is going to tell us an introduction to Azure Key Vault and .NET Aspire. So take it away, Pine.
Hi, friends, and welcome to Azure Developers .NET Aspire Day 2024. This is an introduction to Azure Key Vault and .NET Aspire. I'm David Pine, a senior content developer on the .NET Aspire team, and I'm excited to be here and share these amazing integrations with you. Why is Azure Key Vault so important, and why should you care? Any application that requires management solutions for securing secrets, keys, and certificates can benefit from Azure Key Vault. It's used as a means of centralizing application secrets, where you can securely store secrets and keys, you can monitor access and usage, and you can easily integrate with other Azure services. For certificate management, Azure Key Vault lets you easily provision, manage, and deploy public and private TLS and SSL certificates for use with Azure and your internal connected resources. Azure Key Vault can be used as a key management solution. With Azure Key Vault, it's easy to create and control the encryption keys used to encrypt your data. And finally, the most relevant bits to the .NET Aspire integration with Azure Key Vaults is secrets management. This is used to securely store and tightly control access to tokens, passwords, API keys, and other secrets that your apps will rely on. Secrets can also be used within any .NET application as a configuration source. I've never really been big on slides, so let's jump right into it. We've got Visual Studio open, and I have a sample application that I've written with .NET Aspire that uses one of the Azure integrations. Most commonly, there's two aspects to integrations. That is the hosting bits that represent and add resources to the app host, the model, and the other part that kind of plugs into that, and we'll call those client integrations. Those are more on the consuming end. So on the hosting side, we'll have our models that represent our various resources that we depend on, and the relationships and dependencies between resources, and that's in the app host. The other part is the consuming part, and that can be anything from an ASP.NET Core minimal API, or a Blazor front end, or a worker service, or any other .NET workload that you can imagine that might want to consume said services. This is the program CS file of the app host project. Let's look at the app host project first, though, and I want to highlight that the app host is pulling in the aspire.hosting.azure.keyvault NuGet package, and this is going to expose our resource for Key Vault. So let's return back to the program CS, and we're going to walk through this code to make sure you understand exactly how this is functioning and what it's doing. So the first thing that we do is we walk up to the distributed application and call create builder. And that's going to return to us an iDistributed application builder. We're going to use that builder to express all of our application's resources. In this specific case, we can actually use the isPublish on the execution context to determine whether or not the application is being published into a manifest representation of all of the dependencies, or if it's simply running. If it's being published, we're actually going to add Azure Key Vault so that we can provision and deploy an actual Azure Key Vault resource. Otherwise, if we're not in publish mode, if we're just running, we're going to use a connection string to an existing Key Vault resource that's already been provisioned and exists within Azure. So with that being said, we'll actually declare a secrets variable that is conditionally going to represent either an Azure Key Vault resource or a connection to an existing resource. And once we have our secrets instance, we can actually use that reference to pass in and express dependencies. So on line 12 here, when we say builder.addProject, we're referencing an API service, and we're giving it a name of API service. And we're going to say with reference given our secrets variable. And then we're going to run our application. So in other words, we create the builder, we conditionally specify our secrets, whether or not it's an actual Azure resource that we're going to provision and deploy later on, or a connection string to one that already exists. And we're going to say that our API service takes a dependency on that before we run the application. So let's jump over into the consuming integration. This is going to be an ASP.NET Core minimal API project that we've simply called API service. Like before, let's jump into the project definition itself to see that we have an Aspire.Azure.Security.KeyVault NuGet package. So this is the client integration NuGet package that's required to connect to the resource from the app host. Returning again to the program CS, we have our web application where we create our builder, and we're going to use Swagger and OpenAPI so that I can expose this API so we'll have a front end that we can look at. But beyond that, the main things of concern are these two methods right here. The first of which is builder.configuration.add Azure Key Vault secrets. And this takes that connection name. So this is the same connection name that we had in our app host. And that's very important. That's like the glue that binds these two things together. So when we said in the app host, we're going to add our key vault or our connection string, we named it secrets. We're doing the same thing here. Now this add Azure Key Vault secrets to configuration will actually represent Azure Key Vault secrets inside our configuration. And this is under the covers relying on the Azure Key Vault configuration provider for secrets. The next line to look at is the add Azure Key Vault client, or we named it again with the same connection name secrets. So it's going to rely on the same resource. Now this is actually going to add a secret client to our DI container so that we can request that wherever we depend on it. In this application, it will resolve to a secret client that is hydrated with the correct connection string to our specific Azure Key Vault instance. Now, the last thing to look at is the mapping of the secret endpoints. This is an extension method, and I simply exposed it as an API for secrets. So given our secrets API, we're going to map 3 endpoints: the get all secret names, the get secret by name, and the creation of a secret. Let's look at all of these real quick. The first API is the get all secret names async, and it expects the secret client. Again, this is registered in our program CS, and it's provided through dependency injection. And we're going to use that client to get all the properties of secrets asynchronously given our cancellation token. And this is actually an async enumerable, or in this case, for this specific SDK, an async pageable, which is equivalent. And for each secret property, we're going to yield return our secret name. So this API simply returns an array of names for our secrets. The next API, named getSecretAsync, has a parameter for the secret client, the name of the secret, and a cancellation token. So we walk up to the client and say getSecretAsync, given the name and cancellation token, and we get a response back that is a representation of the Key Vault secret from the actual Azure SDK. And if it's null or the value is null, we're going to return not found. Otherwise, we're going to return OK with an anonymous object that's representing the name that was given through the API and the corresponding secret value. The final API is a createSecretAsync method that again has a parameter for the secret client and an object that's going to represent the creation of a secret as a request model. And all that model has is a name and value, and of course the cancellation token. So again, we walk up to the client and we say set secret async, given our secret request and our cancellation token, and we return back the ID, or in this case, the URI that represents that secret. Great. So now that we've familiarized ourselves with both points of the integration, the hosting integration that represents the model and the client integration that's the consuming part of the resource, let's run the application and take a look at our OpenAPI to test out the app to see how it works. Awesome. Our application has started and it's spun up the .NET Aspire dashboard. And from here, it's going to show all of our various resources. It's going to have our console logs, our structured logs, tracing and metrics. And this is all based on OpenTelemetry for those things. So it's going to represent our single API service at this point, our project resource. And it has these endpoints. So we can see that we have our HTTP or HTTPS. And let's just hit the Swagger endpoint. And this Swagger endpoint has our APIs for our secrets. So these endpoints represent our get of all the secrets, the posting for creating a secret, and getting a secret by name. So let's just execute the get all to see what secrets we currently have configured, and our results are back. So we have two values. The first is the favorite programming language. That's the name of our first secret. And the other is the first programmer. So let's copy that name and let's go back over to the get by name functionality, post in the name of that secret, hit execute there. And it's actually not really a secret. The first programmer is Ada Lovelace. Cool. Let's go back over here and get favorite programming languages, or favorite programming language rather. Execute that. And obviously the secret value is going to be C#. So we can also create a secret if we want. And then let's do that. Let's create .NET Aspire. We'll say the value is for the win. Let's create that. And it's created and has our ID that was returned. So if we go back over here to our get all, execute that, we'll have our .NET Aspire value, and then our get will now return .NET Aspire for the win. To recap everything that we just saw, we looked at first the app host project. We explored how you model resources and dependencies, and we specifically added a resource that represents our Azure Key Vault. Next, we used a client-consuming integration, which pulled in Key Vault, registered the secret client so that we could leverage the corresponding resource from our app host. We were able to spin up the application. Once our application was running, our Swagger page enabled us to execute all of the endpoints that we've configured. We saw then that dependency injection provided our secret client to our various APIs, and we were able to leverage that integration. With .NET Aspire, you're able to easily orchestrate growing applications, and it dramatically improves your inner developer loop. You can use the dashboard to get insights into whether or not there's failures, leveraging telemetry, metrics, traces, structured logging, things of that nature, and it really helps you speed up development. Now, as your application begins to grow in complexity, .NET Aspire really shines. The app host lets you express all of your various resource dependencies, and integrations are seamless. Well, that's all I have for this talk. Thank you so much for joining me today on this Azure Developer Special, emphasizing the strengths of .NET Aspire, where we covered integrating with Azure Key Vault. Once again, thank you so much for watching today. For additional event resources, scan the QR code or visit the link provided.
Thanks, David. That was great. Like I said, David writes a bunch of our docs, David Pine, and he's all around great. So awesome to hear you talk about and kind of introduce Azure Key Vault and Aspire and how those things can work together. So just a reminder, as if you've been hanging out, you've heard this before, check out the collection on Learn with that link. There are links to a challenge on Learn where you can follow a leaderboard on completing different sections of Learn on Aspire and Azure. You can see all the source code maybe not all, but a lot of the source code and PowerPoints from today's talks. And then that's where you'll also be able to find more introduction to Aspire content and the links to these videos when they are uploaded after the event. There's also a survey, so definitely fill that out and let us know what you think of the event. If you want more of these things, if you like the content, if you think the content needs to be more or less deep, whatever it is. But we're going to jump right into James Montemagno, one of my favorite people who have worked on both Maui, .NET Maui, my baby, and .NET Aspire stuff. And he is talking about .NET Aspire's manifest and AZD and Bicep. And then he put the exploding head emoji. So that's how you know it's going to be really cool. But generally deployment and customization with Aspire. And so, James, let's see what you have for us.
Hey everyone, I'm James, and today I want to talk about deployment. Everyone's most fun part of actual creating projects is deploying their applications and getting them out into the world. And there's many different ways of deploying applications. And today I want to talk about what actually happens when you run the AZD up command under the hood and what .NET Aspire is doing to enable that process and enabling other tools in the ecosystem to help developers deploy their applications. So that's what we're going to talk about today. And we're going to go from start to finish and actually deploying our application and showing what's happening under the hood. Now, if you remember though, like .NET Aspire is building blocks for our application development, right? So it offers up a bunch of different things that makes our lives as developers better. It makes our applications better and helps us build better apps. And all the things are different optional, right? So things like smart defaults, enabling those health checks and resiliency, you can turn those on, you can customize them how you like them for your app. You get a beautiful developer dashboard for local or using it wherever you want to deploy it. Orchestration to boot up all of your applications together, which is sort of the key to deployment, which we'll talk about here. And of course, service discovery and integrations enable us to really make our applications rich with functionality. Now, the one area though that we're going to focus on today, and which often we don't talk about enough, is deployment, because that's sort of the end thing. That is something that is unique to different applications. So yes, we do see great examples of how to easily get your applications up and running with great tooling. How does that stuff actually work? But before we actually go there, I want to have a sit down and talk a little bit about deployment. Okay. When we're deploying our distributed applications or any application, it's kind of tricky, to be honest with you, because if I was to survey everyone watching right now, what is in your application? What services and integrations are you using? Where are you deploying them? How are you deploying them? Do you want to use Kubernetes? Do you want to use ACA? Or do you have a bunch of functions? Do you want to use app service? Are you using containers even? What is in your application? What are your IT and security requirements? That is going to be different for every single application, every single company out there, which means at a high level, deploying applications is complex because it's complex. It's just complex. It just is, right? We have all of these different sort of roadblocks that get in our way, which makes it really hard for there to be a perfect one-stop shop for deploying every single different type of application in the entire world, right? So when we take that in context, we say, okay, knowing that one, deploying applications is difficult and it's complex and they're all different, there's a lot of choices out there. Well, how can .NET Aspire help me deploy my applications better and faster? Or how can I use .NET Aspire in my applications and continue to deploy how I want to deploy today? So let's talk about those deployment options. Now, when you have .NET Aspire in there, we've orchestrated everything in our app host and I want to deploy things. So how do I do it? Well, first, you could just continue to deploy like you have been today. That's option number one. This is something that people ask me, like, well, I'm already deploying. I already have a CI/CD pipeline set up. I already have my Docker files. I already have Helm charts all set up. I already have, everything all set up already, right? My IT pros and everyone in development is super happy with all of our requirements that we've met. We're deploying it here and here and 18 different places. I just want to keep deploying it there. And the answer is, yeah, just keep doing that, right? Just keep deploying your application as is. And you might have to make some subtle changes to it. So for example, if you're using service discovery and you're adding integrations, well, you're going to have different connection strings. You're going to have to figure out, okay, are we going to reuse existing connection strings, update that in my app host or different areas that I'm looking for connection strings? Or do I just update my actual connection strings on my environment variables on my cloud provider to reflect what is being generated for me? And you might be saying, well, how do I know it's generated without just going into the dashboard and looking at every connection string? And I'll show you, and I'll tell you exactly how this is happening. Now, beyond that, there are other sort of tools to help streamline the process. And what's happening here is that we have everything in the app manifest, and there's a process in between here and the tooling, which is generating a schema for our application. And that's what we're going to talk about today. So that schema can actually be used by other tools like the Azure Developer CLI or Aspirate, for example, that take them and help us deploy our applications into other areas and work in other tooling such as Visual Studio, which uses the Azure Developer CLI to go and deploy our application to Azure Container Apps today. Now, all of this is optional, right? You can continue to deploy exactly. You can choose to use Aspirate or Azure Developer CLI. You can choose to check out the manifest and Bicep files and a bunch of other stuff. That is totally up to you. You get to choose what you want to do, right? There are so many options available because of this setup. But let's say we were, for example, using the Azure Developer CLI and we wanted to deploy our application with AZD up. How exactly does this work under the hood? So let's walk through the process here. You go into your terminal and you say AZD up. The first thing that is going to do is call a .NET run command. Now it passes in a bunch of different commands and it produces an Aspire manifest file. Now that Aspire manifest file, it serves as a reference guide for deployment tool builders such as AZD to figure out how to deploy .NET Aspire projects on a specific hosting platform, whether that's on-premise or in the cloud. And this is a JSON format. We're going to take a look at it today. Okay, so we have that Aspire manifest. Then what? Well, AZD up specifically will be then calling AZD provision, which generates Bicep files in memory actually by default. And you can think of Bicep as sort of definitions for deploying Azure resources. It's kind of like TypeScript for ARM in a way, in there, as once described to me. And once it's generated this, it's going to trigger Azure's ARM APIs in your subscription and resources groups that we set up earlier in the process. Now from here, it's then going to call AZD deploy, which executes and uses that same exact Aspire manifest. Now, part of this, it's going to call .NET publish to build container, and it has a different publishing support to generate those container images. And then once it has everything, it's going to push to our ACR registry and create all of our resources based on those Bicep files that were created for us automatically earlier. And that is the pipeline of what is generated for us. So let's actually do that. Let's deploy something. Okay. So over here, I have my tiny shop, and this is a tiny little shop that has a back end and a front end over here. And if I open this up, we can see that, yeah, we have our Blazor front end here with a bunch of products and this outdoor products here in the tiny shop. And then we have our resources. This has a Redis cache. This is just using the Docker IO container image over here. And then it has a products and store over here project. We can see that it's using all the telemetry, all the things, all the different products, all the gets coming in here as I'm using the application here. So that is my application. Okay, so I'm going to go ahead and close this down here and stop debugging. So we first see that the cache is being used by the products API. And then over here, the store is using that API. And it's marking this external HTTP endpoints. And that specifically is something that needs to be exposed to the internet. So that is something that we're sort of inherently telling Aspire to do something with, and to do something with is specifically put that in the manifest. So whatever tooling is built on top of this knows what to do with that. Okay. So that is our project. So you can imagine this builds up over time, but I want to make it consumable so you can see what's going on here. Okay. So normally I would right click publish, come into my terminal over here, and I would say AZD up and AZD in it and all these things like that. We're not going to do that today. We're going to actually see what's happening under the hood when I see and say AZD up. So the first thing that I'm going to do is I'm going to run a command, which is .NET run, and then I'm going to pass in some additional parameters, such as the publisher, which is going to be a manifest, and then an output path, which is going to be aspire manifest.json. So that's what we're going to do. This is going to build a project, take a look at everything that's sort of happening over there, and generate a manifest for us and put it into the app host. Okay, so what is in this Aspire manifest? Well, again, like I mentioned earlier, this is really a reference guide for the tools, in this case, AZD, to figure out what and how to deploy, what is in my application. So the first thing we're going to see here is that there are some resources. In fact, it's all resources over here. We can see that there's a cache, which if we look back, that's the key. That's the little key that I put there as the cache. It's a container type. It's going to give us connection string, which are the cache bindings for the host and the port. It specifically is going to use the Docker.io Redis 7.2 image, and then it gives us the bindings here. Over in our products, what we're going to see is that, yeah, this has a type of project, specifically this project path. So in contrast, the type was container and it was specifically the image. And then this shows me all of the environment variables that need to be set up for us. So connection strings underscore cache. So that is the connection string for the cache, and that's using the connection string. We can also see things that are configured, such as OpenTelemetry over here and the forward headers that are enabled and HTTP ports here. It's also going to show us the bindings. So HTTP and TCP and our transport and for HTTP and HTTPS. More interesting over here, what we're going to see is that we see the store. Now the store, for example, is going to be another project. And in this case, we're going to see not only all the normal ASP.NET Core and OpenTelemetry stuff, but we also see the services underscore products underscore HTTP. So this is that service discovery. Same thing here with that connection strings underscore cache. So here, this would be the specific connection string, the environment variable that I would need to set up. And then we can see specifically over here that the bindings are telling us that it's HTTP and HTTPS, but note that external is set up here. Okay, if we go back over here with external HTTP endpoint. So when we define that, we said that please put into our manifest file that we would like that to be exposed externally, which means the tooling will pull that up automatically for me. So that is our Aspire manifest. And this can be used by any different tooling out there, such as AZD. So what does AZD do with this? It's a great question. So what we're going to do is we're going to come back over here and we are going to now say AZD infra synth. So synthesize the infrastructure. So this now is going to analyze the .NET Aspire project and create a bunch of files for us. Cool. And in fact, they're all here inside the infra folder. So if I drop this down, we're going to see that there's a bunch of different files. The first thing that we're going to see is the main Bicep. And again, when I say AZD up, this is generated in memory here. And this is going to be generated every single time I say AZD up or change my application. So this is always changing. You don't want to like use this as infrastructure unless you're going to regenerate it every time. So if you make changes, it will be overridden every time when we do this, right? So here we have our main Bicep. So this is our main entry point into deployment. So we can see things about the subscription, the environment name. We can see the different resources, the tags, the different, output for managed identity and different connection strings that are going to get set up automatically for us. We can also see our parameters that are piped in. So our principal ID, environment name, and location that are set up here. We can also then go into our resources.bicep. And what this specifically is doing is defines the Azure resources required to support the .NET Aspire project model. So in this case, it's going to show us the managed identity, the container registry. It's going to show us our authorization role assignments that are set up for us automatically. It's going to then put in operational insights for log analytics, manage environments, set up our Aspire dashboard here for us, and it's going to go ahead and do everything else that is needed. Now, on top of that, though, we can also see the cache template YAML, which specifically is the definition for that cache. So we can see everything that's going to be deployed here. And we also get one for the products, and we can see what's going on exactly in the location, if the ingress is external or internal, if it allows insecure or not over here, all the things that were generated off of that Aspire manifest. And the same for the store. So we see this here, except for here, the external is the true for the ingress. So we see that all up right there. So that is how we go from first generating the manifest to how AZD takes it and synthesizes it directly into infrastructure that can be used. All right, let's go ahead back to the slide really quick here. So I may be saying, well, how do I learn more about this and what else can I do? Well, first and foremost, there is amazing documentation that goes through every single bit and more of what I just showed you, how you can use it in your development process. Go to aka.ms/.net-aspire, and that'll take you there, and then go to the deployment section that will go through everything. I also want to point out Aspirate. Aspirate is an open source project that uses the same exact Aspire manifest file, but enables you to basically create infrastructure for other deployments, such as Kubernetes servers, for example. So definitely check that out as well, based on what your needs are. It's going to be really amazing to see this community flourish and help us deploy to many more places based on our application needs. All right, that's going to do it for me. So definitely make sure that you check out all the event resources at the aka.ms below that I'm sure is in the chat right now. And that's going to do it for me. So thank you so much for watching. I really appreciate it and hope you learned something cool about how that AZD Up works under the hood. Cheers.
Awesome. Thank you, James. That was great. Great crash course on head exploding .NET Aspire manifests, AZD, and Bicep. Bicep is terrifying, so it's nice to have someone explain it to you politely. But the links he showed, definitely check those out. Send us your feedback. We're going to keep on chugging to Jorge Arteiro, who is talking about just deploying .NET Aspire projects to Kubernetes. And James Montemagno just mentioned the Aspirate project. And so you might be hearing more about that in this upcoming talk. So take it away.
Hello, everyone. I'm Jorge Arteiro from the Cloud Native Advocacy team at Microsoft. I'm going to talk about deploying .NET Aspire projects to Kubernetes, specifically to Azure Kubernetes Service. Let's get started. The first thing is, let's recap what's .NET Aspire. We're going to focus today on .NET Aspire deployment specifically. But don't forget, .NET Aspire is about observability with OpenTelemetry, about resilience, scalability, and all running locally. And why deployment? I work with a cloud data, I work with Azure Kubernetes Service team, and we're going to see how can we get your .NET Aspire project, the app host project, and we deploy these on Azure Kubernetes Service. Remember, you can deploy a .NET Aspire projects using Azure Dev CLI or through Visual Studio, but we're going to focus on a specific tool for Azure Kubernetes Service where you can generate some of those manifests for Kubernetes, the tool called Aspire 8. We're going to see that on the documentation as well. Let's go for that. The first thing, let's get the code, GitHub.NET presentation, let's learn .NET Aspire. Let's jump to my code. And that's the source code. I'm going to use the solution inside the folder complete, the full solution with app host, the front end, the web hub, and the API backend. We also have Azure Kubernetes Service. We're using AKS Automatic, that's in preview, where it's fully managed. You don't have to care about your workloads. You're going to create the nodes dynamically for you, and you're going to scale down when you don't need that. That's the new option. I recommend you to have a look. It's very simple as well. And we're going to follow the documentation to deploy using Aspire 8. I have a few commands like initialization, generate the manifest. They can generate Kubernetes YAML files, or also can generate Helm. Or you can apply and destroy those manifests through the command line tool as well. This tool was done by third party. And if you uninstall, we do .NET to install Aspirate is a pre-release version that you can install and also update. I'm going to use Helm. That's another tool for Kubernetes. You can install on Windows or Mac. And I'm going to use Headlamp. Lamp is a nice IDE that where you can watch your cluster and you're going to look the AKS automatic cluster that we have running here at the moment. To get started, we're going to open the project of Visual Studio. And like I said, I have my app host. And the application is pretty much the front end, web application, the API, and also we're using Redis cache, or the caching of the page and the API. We're using Redis cache there. Then I have those three components. I'm removing the Redis commander because we don't need for this example. And if I run these, I can run the application locally as usual. And you can see the dashboard and everything. But we want to run these on Kubernetes. How can I do it? The first thing you have to do it is using the Aspirate. Go for the command line for the heavy host project, and you're going to run Aspirate init. You can initialize your heavy host project with Aspirate. You're going to ask you a few questions. The first question is, when I use another registry, I'm going to use my local Docker desktop. Remember, we need Docker desktop or another engine to run. I'm using Docker desktop. And we need this to run .NET Aspire. Now I'm going to use the local one, means that I'm not going to set any other registry. You can. And I'm going to set a specific prefix because my Docker Hub is called Jorge Arteiro. And all my Docker image will be starting with the name Jorge Arteiro / something. You can use your Docker Hub, for example, or your container registry. And I'm not going to select a specific folder. I'm going to use the default folder where the manifests are going to be generated. And that's it. With this one, I have inside my project aspirate.json. Okay, if we have the registry settings will be here. Otherwise, you're going to use Docker, and all my prefix will be using my Docker Hub. What's the next step? Next step is to the same command, but now we're going to generate. The default will be YAML files, Kubernetes YAML files. They're going to ask you, just like a password, could be anything, just to encrypt possible secrets that you have on your application. You do twice, could be anything. Now going to be saved, will be just locally. And they're going now to generate the manifests. Take some time. They're going to also ask you which components you want to do it. I'm going to select all. You can pick. If you don't want to do caching, for example, you want to create Redis cache on Azure, that's fine. Otherwise, you can run Redis cache as a container as well inside Kubernetes. Then they ask me, do you want to do the Aspire dashboard? Yes, I want to deploy the Aspire dashboard as well. And then they're going to do .NET Publish. Why? .NET Publish, you can create the container. They're pretty much creating the API container image, not the container instance. And I pretty much those two images here, API and my Weather Hub. 7 seconds ago, they recreated the image, and they're going to do for both API and for the Weather Hub as well. When both are done, I recommend you to set for hours. Hours put the image, because Kubernetes sometimes when using the tag latest, if you don't do that, any change on your applications are going to be redeployed. You want to deploy on a custom namespace. Yes, I'm going to set a name. I call this Weather Hub. Otherwise, if you don't set this namespace, you're going to use the default namespace on Kubernetes. And the last one, if you want to create a top-level customize, I recommend you to keep yes. And after that, all your configuration is done. We have a new folder, aspirate.output, where all the deployment YAML files are created for each one of the servers and also for the dashboard. You have the manifest.json file that describes pretty much like a Docker Compose file, all the servers. And this manifest file is used by the Aspirate to create the YAML files and all the Kubernetes manifests. You have the state where they keep all that configuration that we do on the command line that you don't have to do again and again. And you have the Aspirate with the prefix and the first initialization that you do. Next command I have to do it is apply those configurations. You have those configurations there. If you apply, what's going to happen? You're going to apply each one of those manifests for each one of those servers. And you're going to keep the same configuration we did before. We type the password, that same password we used before. We keep yes. You're going to handle all the deployment to the cluster. And then we're going to select the AKS automatic. Using the context that I have already, my connection to my cluster from my Docker desktop. And we should now have all these applied on my cluster. If I go back, AKS automatic. Yeah, what's going on at the moment is the deployment is pending. Why is pending? Because the cluster is going to scale up. I'm going to create a new node for my application because those are just system node roles. I'm going to create a new node for my application here to be able to run those pods. That's going to take some time. Okay, maybe 40 seconds, 50 seconds maximum. Headlamp is very nice for that. You can see the node being created, 13 seconds, and you're going to see the workload being created as well. Then you're going to use this namespace where the help, the namespace that we decide to use. That's one thing. Another thing that you can do is, in the meantime, you can also create Helm, the package management for Kubernetes. And to do that, we can use the Aspirate generate output format Helm. Very similar. We can skip using the same configuration, type the same passwords for encryption. I'm going to ask you the cluster that you want to run that. In this case, we don't need it because they're just generating the configuration first for Helm. And they're going to also try to rebuild the image. Because AKS is on Azure and you need access, remember that you need to, once those images are on your Docker Hub, you have those three images here, you must push those images. You can do something like that. You can just run, I can run that for you. Let's finish generating the YAML file or the Helm charts. Then the Helm is going to be created also inside the folder, a new folder called charts, and also the templates. A different way to do it using Helm is more templating, and the other option is more using customize. That's a no template option as well. Helm is very popular in production, and now I have Helm. How can I deploy Helm? To deploy Helm, remember, you need the Helm command line to be installed. But before, I want to make sure that I'm going to push the image. Okay. Even before I deploy to AKS automatic, you should do that to make sure that your image is there. If you decide to set your configuration for your container hash, probably Aspirate is going to do that automatically for you. I'm doing manually in my use case here. But let's go for my headlamp and see AKS automatic is already running like 3 minutes ago. All my pods are running. Why I like to use headlamp? Because you can just come here and you can click on the pod and do a port forward. And now you can test from the Kubernetes on Azure. You can test your application. The same thing you can do for the dashboard. You can get a Aspire dashboard. You can do a port forward. And you can test from Azure Kubernetes Service. You are doing a port forward from your machine. And you can play with the Kubernetes dashboard. Everything run on Azure. It's everything running on here. So if you want to, after you push your image, finish to do a Helm deployment, if you want to do Helm and do a deployment also on my AKS automatic, On this time, I'm going to use a different namespace. I'm going to use namespace weather and not weather have. There will be a duplication, will be a second deployment of my application on the same Azure Kubernetes service. Means that like two developers, they could be using the same cluster. If you run this command, I need just the where your chart is, the folder, and you need the file for the values. Values are pretty much the parameters of your Helm chart. If you go back there, I should have now another namespace for weather and weather hub. And the containers are quickly being created there. Now it's container being created. The same thing. Yep, everything's running. I should be able to do the same thing I did of the first version. And I have now my Helm version of the deployment. With this, we conclude. You can also remember, you can do aspirate, destroy. You can do also, you should destroy that. I want to clean up everything that I deleted. You can destroy everything. And at the end, you can do for the second deployment, you can do a Helm delete. And now you should have a clean, all the pods being terminated already. And the nice thing is, in a few seconds, this node will be deleted because you don't need that anymore. And you don't pay for these anymore. Thank you so much. And please get this QR code and follow all the resources of the .NET Aspire Day. See you next time.
Awesome. Thank you so much, Jorge. We are coming to the last talk of Aspire Azure Day, or Azure Developers.NET Aspire Day is the official name. So we are going to go right into the final talk, and then we'll wrap it up at the end with a little bit about all the links and all the things. But we're going to pass it over. We just saw deploying .NET Aspire projects to Kubernetes, and now we are going to see something even crazier, which is Aaron Powell showing us client-side JavaScript OpenTelemetry integration with .NET Aspire. So that's a lot of words, but Aaron's going to describe it for us. So see you on the other side.
Hi, everyone. Welcome to today's session, where we're going to learn about how we can use the JavaScript, build a JavaScript front-end application and connect that with the .NET Aspire dashboard so we can get end-to-end tracings and telemetries and things like that. The kind of stuff that we love about the .NET Aspire dashboard, but doing that across a couple of different runtimes. My name is Aaron Powell. I'm a principal cloud advocate here at Microsoft on the .NET on Azure advocacy team. And I hope at the end of this session, you'll feel more confident in trying to build applications that are going to span multiple different languages and get that rich sort of telemetry and insights that we can get with the .NET Aspire dashboard. From a slides perspective, well, pretty much done here, because I really just want to get in and show you how we can build this. So with that in mind, let's jump over to my VS Code instance and have a look at the kind of application we can build. So I've got an application here. It's already got the .NET Aspire app host configured. I have a .NET API that's going to expose a couple of HTTP endpoints that we're going to consume. We have our app host configured where we have our services and all those sorts of things set up. But instead of having a front end that's written in, say, Blazor and running as an ASP.NET web application, I'm running this as a React application using Vite. And I'm starting that using the add npm app for .NET Aspire so that the app host will start that up. Now here in Bookstore Web, well, I'll find a pretty standard Vite application. Now I have my package JSON, it's in TypeScript, so I have some type safety, all those sorts of things that we were expecting there. But this is just it's a front-end application. I ideally deployed as, say, a static web app that I could have on Azure Static Web Apps. I could have it inside of a container app with something in front of it, or whatever the hosting model you want to tackle with would be. here's the application. We'll see that I have my home page. I can then expand this out, and I can get a whole bunch of books back from the database that I have behind the scenes. There's been seeded with data in there. I can create new books. And as I click around, if we come over to the Aspire dashboard and look at traces, well, we'll see that we're starting to get some trace information here. I'm seeing a call to API/books, and that's going to return me all the books. And well, I can see that then hit my my SQL database. All those sorts of things that I kind of want from an Aspire set of telemetry, and what I can see in the dashboard, that good rich logging and tracing and all that kind of stuff. But I'm losing part of the boundary. I can only see the .NET component of this. I know that API/books was called, but who was the caller? What was the things that happened that led up to that? And we're kind of losing that. Whereas inside of a Blazor application, well, we'd probably get some of that telemetry as well, because I can see that kind of end-to-end clicking around and whatnot, because it's all within inside of a .NET context. But we're not in .NET for our front end, so how do we tackle that then? Well, this is where we can use the power of OpenTelemetry, because it has got SDKs for pretty much every language that we're going to need. In this case, obviously JavaScript. Now, I've done some setup initially just to get the ball rolling here. I've gone through and I've installed the various NPM packages I need. So things like the OpenTelemetry API, the tracing web, because this is running within inside of the browser. There's a different set of things if you're going to use it with Node.js and do it entirely on the server. And some of these things like zones, we'll talk about in a moment. I've also set up to use the OTLP tracer, and then this is going to use a HTTP tracer so that it sends that over the HTTP requests to my Aspire dashboard. If we come back into Aspire dashboard, and I have a look at my web resource, the details here, pop this to the side, we can see that it is passing in all of the endpoint information, such as where my endpoint is. And this one I've configured to, it's running on localhost 21161. And I've also reconfigured this to use HTTP instead of gRPC as the protocol, because I need to be able to make requests from the browser. Now, to do that, we need to make sure that we configure the Aspire dashboard to launch with HTTP as the protocol. And we do that with inside of our outpost on the launch settings. I'm setting a HTTP endpoint URL for the dashboard so that it knows to start that with HTTP requests, and it can and we can do the OpenTelemetry tracing into that. Okay, so now that the environment's ready to go, let's start putting some stuff in to make this work. I've created a new file called instrumentation.ts, where I've gone ahead and kind of set up the basics of what I'm going to need to instrument telemetry. And I'm only going to worry about tracing, not metrics, for the scope of this. I just kind of don't have enough time to cover every aspect. But I have this initialize telemetry function. I'm going to take the endpoint URL, and I take any headers, such as the authentication headers that I'm going to need to talk to my OpenTelemetry endpoint within inside of the .NET Aspire dashboard, and any other attributes that I might want to attach to that as it gets started. Inside of the main.tsx file, I'm going to initialize the telemetry using the environment variables that were provided from the Aspire outpost when it started up. Things like our endpoint, headers, and attributes. Obviously, you pass in any additional ones that you want there. Another one that I've got here, just to show that you can access them within inside of this file if you wanted to instead, I'm using this service name. So that's how it knows the name of the service as was defined in our outpost file. And we log that out so that we have our tracings connected appropriately. So I'm going to set up some attributes that are going to be needed here. And then we're using a web tracing provider from OpenTelemetry. So this is how we're indicating that this is capturing traces within inside of a browser context, and that we can then send those somewhere. I then have to set a span processor. So the thing that is going to capture those traces and make sure that they get processed and output to a location. So I'm just using a simple span processor. So this is going to do every single one. You can do batch processing if you prefer. And then this is just going to put it to the JavaScript browser console. So I'm using a console span export.
I'm then then configuring a context manager. So the context manager, I'm using a zone context manager, which is going to create an artificial, essentially an async boundary around the events that are happening within inside of my OTLP environment, so that we get those, so that we can connect things together appropriately. This is just more of a nuance within inside of JavaScript because of how JavaScript deals with asynchronous processing. I don't have any instrumentation set up just yet. We'll do that in a moment. But so with all that kind of set up, our browser should have reloaded. And if we pop open the dev tools to the side, let's just resize that a little bit. Well, we won't see anything just yet because, well, while I've got it set up, I'm not telling it to try and capture anything. So we need to capture some information. And for that, I'm going to have to add some instrumentation. So what do I want to know about when requests are happening? Well, there's a lot of different ways we can instrument. Like kind of that built-in instrumentation, like we get when we use the .NET Aspire integrations, how it automatically does instrumentation like down to SQL queries. Well, I can do a similar thing in JavaScript. I'm going to use, say, a document load instrumentation. I'm going to import that from a npm package called the, unsurprising, instrumentation document load. We'll add that in, we'll save that, and then if we jump back to our browser, we'll say, boom, I've actually had a whole bunch of stuff dumped into my console. We expand out some of these, we can see, well, this is some of the things that have happened. We've done like a resource fetch, and it's tried to get it's got a particular resource. We have a look at some of the attributes. We can see that was the OpenTelemetry SDK JavaScript file. So these are the resources that were fetched by the browser to load the page. We can have a look. There's a whole bunch that have happened there. But if we come into the Aspire dashboard, we'll see that, well, still not getting anything in here. I have my HTTP request for my API service, but I'm not seeing anything. And that's because my instrumentation, sorry, my exporter is only going to the console. But if we were to add, say, a provider, and instead of using a console exporter, we'll use the OpenTelemetry trace exporter, and then provide it with these OpenTelemetry options that are defined up here. So that's the endpoint and custom headers. Now, if I hit save, we'll come back to our browser and reload this page. We'll see that we still have everything that appears there. But now, look at that. We have a new entry inside of the .NET Aspire dashboard, which is our web traces. If I click on this, and we'll see document fetch. We can have a look at that, and we'll see that it's tried to get the client. We've seen that we've got the main TSX. We'll see all the other NPM packages and JavaScript files that we were expecting. They've all been captured. So now we're tracing what's happening within inside of our browser, seeing those files. Now, this obviously can get quite chatty, so maybe you want to conditionally include this one or have ways that you can enable or disable that kind of tracing, but it's there. Like we're starting to pump information from our JavaScript client to our server. But, well, I'm doing a HTTP request here. I'm using the fetch API, and I want to get back let's get back the list of books. But how do I do that in a way that I can actually then connect that to the request that's happening on the server? Well, for this, I need to add another bit of instrumentation. And this, I'm going to use the fetch instrumentation. Adding more. With the fetch instrumentation, I need to tell it that, well, I'm doing this with inside of this is doing a clause request, so it's going across origins. So I need to make sure that I am grabbing, I'm telling it to actually capture those things across. So I'm just going to copy from my sample code rather than having you watch me write out a regex. So we're going to say, I want to propagate trace headers to any cause URLs that are happening. And anything that is just an API request within my environment, we're going to capture that and connect that together. Now, let's go back to our browser. We'll reload this page. And if we come back to our traces, ta-da! Now we see the API service, instead of it just being an isolated one like we were initially having, or disconnected from the web requests, we can see that happened here. Our web HTTP request happened.
It was calling API books, which resulted in the call to API books in .NET, which then resulted in a call into the SQL client to return data from our SQL server. Awesome. But what if I wanted to go a step further and add some like details about where that went inside of my environment? Well, let's come into the books.ts file. So this is my little API wrapper. And let's go to this fetch books method here. And instead of just direct returning the API call, I can then wrap this inside of a tracing call. So I could return a trace from the OpenTelemetry API with inside of with inside my NPM packages. And then I'm going to get a tracer. I'm going to get a tracer. I'm going to call this book web store. And look, we'll let Copilot do some completions for me. And then we'll just close off some of these parentheses. Save that. And we'll have a look at, sorry, that should be start active span, not start span. So we're going to start the active span. So we're going to get a tracer. So this is indicating that this is a series of connected events. We're then going to get an active span. So this is the thing that we're actually going to appear. It's actually going to appear with inside of the Aspire dashboard when we look at it. And then this callback gives us a span object where we can add additional information. Or at the very least, we need to call span.end. So we tell when that environment has that trace has ended, and we will stop connecting them together. So now let's come back here, reload our browser, come into our traces, and now we have two from the web. Fetch books, which resulted in a HTTP call, which called the API, which called the SQL database. We can even go up one more level to where, like, because I don't know where this API is being called. Well, I mean, I do because I wrote the application, but I have no kind of insights from my tracing. So again, we could go return a trace from here, and then we'll do just call a bunch of stuff like that. And then let's close off our parentheses, bracket. There we go. So now we can wrap that again in another one. And again, we're going to do a span.end. And I'll also do a span.end up here, span.end up here. So in case we have an error, span.end will report that. And I need to put one more in this place. But I can also add additional information. So we could say I want to do span.add an event. I want to say fetching book ID. Let's save that. Come back over to the browser. We will reload the page. Oops. Did I put that in book or did I put that in books? I think I put that in an individual book. That's all right. We can click through to an individual book. We'll see here, right down the bottom, the book loader got called. And then we can have a look at the information with inside of this. So book loader, and then inside of our events, look at that. We've added additional information into that. So now we can see from where we've started with inside of our component in React that is actually calling something. It is then calling across to like an API service we've got with inside, or an API file we've got with inside of our JavaScript application, which is then making a HTTP request to a .NET application, which is then calling a SQL database, and we can see that kind of end-to-end telemetry tracing. And that pretty much brings us to the end of time for today. I'm going to jump back over to my slides because we are done. I hope that's been useful and informative. If you want to reach out to me, get in contact, ask me any questions about this session, I mean, obviously, drop comments in the stuff below the video, or reach out to me on my various social media platforms. But like I said, that's all we had time for today. Thanks for joining us at the event, or watching the recording on demand if that's where you're consuming this for. And I look forward to seeing what kind of applications you build with the .NET Aspire dashboard, especially if we're looking at doing it cross boundaries, JavaScript to .NET or any other language in between. See you next time.
Thanks, Aaron. That is awesome. We are going to wrap this up with one more list through all of the links and all of the things today. I hope you all enjoyed this content. First and foremost, the home base for everything from today is going to be at the link that popped up right now, the .NET Aspire Day collections. And that has links to some sample code, some of our Learn modules, different web pages, all the content you could ever want. And then there is the Learn Challenge for .NET Aspire Day with Azure developers. You have 30 days, a little bit less than 30 days, 29 days and 20 hours to complete a certain amount of learning on Microsoft Learn about Aspire and Azure and all that stuff. And then you get a benchmark and kind of like compete on like a leaderboard against people. So that's very, very fun. I've seen a lot of people do it and really enjoy it. And I love seeing the tweets at the end of the challenges. And then finally, there is an event survey. So please fill that out. Thank you so much, Jamie, Katie, and John, who have been running this all day and have been popping up all of these links. The survey is going to go straight to them and to me, and it's going to give us all the feedback about, you know, what you liked about the event, what kind of content you wanted, all that other stuff. And the next time I will be seeing, hopefully all of you, is at .NET Conf, which is an online, fully virtual event. It will be November 12th through 14th. It kind of coincides with the release of .NET 9 and Aspire 9, where we are shipping a lot of new and exciting features, specifically for our Azure developers using Aspire. So I hope you all enjoyed. Catch me online. I can't wait to see all your comments on the videos and your survey responses and hear about what we can do if we do this kind of event again. So thank you, everybody.